Good morning, and welcome to the session I'm delivering on Inside GPT, Large Language Models Demystified. This is probably about the 6th, 7th, maybe 8th time I'm delivering this session. I've been doing it for probably about 9 months. I'm also still working on the session. I was adding and modifying and changing slides. So this is kind of a work in progress as I learn more about how GPT works. And what I'm going to be going through is some quite advanced stuff, looking at kind of how language models work, and also the maths that goes on inside language models. A bit about myself. My name's Alan Smith. I describe myself as a developer, trainer, mentor, and evangelist. I love writing code. So ever since I started my IT career way back in 1995, I've stuck with working with code in various languages. These days, I'm pretty much programming in Python most of the time, working with a lot of AI and machine learning projects. I also deliver training courses, both kind of public courses, on-site courses for companies. I've also recorded some courses for Pluralsight. I work as a mentor. I'm mentoring some other teams to kind of help with AI projects. And I like to look at new technologies and talk about those technologies. Microsoft used to call this role as an evangelist, and for some reason I've still got it in my slide deck. I work for a company called Active Solution. We're based in Stockholm, Sweden. Jakob also works for Active Solution. He's presenting later today. And I've had the Microsoft Most Valuable Professional Award since 2005. When I got awarded for BizTalk Server, and I've been in BizTalk Server Connected Systems Integration Azure before I actually got put into the AI group. I do quite a lot of work with the community. Mostly these days, I'm working on a YouTube channel. So one of the other sessions that I do is GPT versus StarCraft, where I'm using GPT-4 to come up with strategy for StarCraft games. I'd recommend watching the YouTube video. Unfortunately, the demos don't work too well on that when I try to do them in presentations because of the randomness of the game. But the stuff on YouTube, I've edited that so that tends to work well. So I'd like to thank the other YouTube presenters who've really helped me to get a grip with how language models work. I think the biggest shout out has to go to 3 Blue 1 Brown for the last 2 or 3 videos that are looking inside GPT, covering kind of the same stuff that I'm covering today, but with his style of animation and explaining how the maths works. Also, Andrei Karpathy has done some great videos explaining how language models work. They're well worth watching. So we've all been using GPT for a long time. We go in, we ask it a question, and it basically generates this text. We see the text being generated word by word. It's actually being generated token by token. And we'll talk about how that mechanism works a bit later on. So we can go in and we can say, how do I make cheese? And it comes out with an actual description of how to make cheese. I love to know how things work. So how does this work? What actually makes this tick? How can it come up with all of these different answers to all of these questions that we can ask? The models themselves, if we look at what GPT does, the only thing that the models will do is that when we give it a sequence of tokens or an input of text, the GPT model will predict the probabilities of each token being the next token in the sequence. We'll look later on at the model vocabulary. There's a token vocabulary, which in the GPT models is about 50,000 tokens. So if we feed in a sequence of these tokens, it will just give this probability distribution of what it thinks the next token will be in that sequence. So if we say the cat sat on the, and we feed it into a GPT-2, which I'm running on this machine, it's going to come out with this kind of series of predictions, with floor being the most probable token at 7.64%. Now, the reason that we see, when we're in GPT, this text coming out kind of token by token, is what the model will do then, is it will take the token for floor, it adds it on to the input, it sends that sequence into the model, and then the next thing that comes out is comma, being the most probable at 26.14%. So we put comma on the end, we feed that token sequence back into the model, and it comes out with and at 4.78%, and then we stick that token on the end. So this is basically what the models are doing. We'll see that that's not optimal, and we'll see later on that there's other things that we can do to generate better and cleaner outputs. So this sequence prediction problem is very challenging when we're working with text because these sequences can be of variable length. We can say the cat sat on, or the king of rock and roll is Elvis, or we can generate code by putting in a comment, load trainingdata.txt into a list and display the top 10 lines. And the probable tokens after this comment is going to be the code that actually executes what is described in the comment. So that's why we're using copilots, and it's able to generate code for us. But all it's doing is really just giving out the next tokens in the sequence. The sequence order is very important. If we say the film was not bad, in fact it was very good, versus the film was not good, in fact it was very bad, all we're doing is really swapping two tokens in that sequence, but the actual sentiment of that text is changing dramatically. It's giving it pretty much the opposite sentiment. So the order of these tokens is going to be very important. Also, we have to deal with long-term dependencies. The cat sat on the floor. It had just been cleaned. So then it had been cleaned, so it is going to refer to the floor. Versus the cat sat on the floor, it had just been fed. Well, it had been fed, so it, in this case, is going to refer to the cat, because we feed cats and we clean floors. So it needs to understand these long-term dependencies, and this is a simple example, but when we're dealing with much more complex examples, such as the poem, The Boy Stood on the Burning Deck, the boy is mentioned in the first line of this poem, and in the second column, it says, upon his brow he felt their breath. So his is going to refer to the boy. The father is also mentioned in the poem, but the language models are able to understand that when we say his in that particular verse of the poem, we're referring to the boy. And then we have the concept of prompt engineering. Prompt engineering is what we actually feed in to the large language model. So it can answer the question, how do we make cheese? We're not just sending in how do we make cheese when we're using GPT. There's a whole bunch of other stuff. So typically, we tell the language model what it is. You are a friendly and good-natured chatbot. We also tell it things that it shouldn't do to prevent the users from doing things like jailbreaking or getting it to generate inappropriate responses. The actual prompts are a lot longer than that, but that's basically what it's saying. And then we actually feed in the user's question. And after all of that, the next tokens in that sequence is hopefully going to be the answer to that question. We also have something called retrieval augmented generation, or RAG. You will have heard of this. I think Tess Ferendes was talking about this earlier on in the conference. And the general thing is that the models have a cutoff in their training data. So they're trained on data, and then we have this cutoff in the training data. And they don't know anything after that actual training data cutoff. So what we need to do is to provide information. If we ask it, for example, who won the Eurovision Song Contest in 2024, the actual model doesn't know that. So by retrieval augmented generation, we can go out to another system. It could be a search engine, could be something else. And then we can actually feed in information into the prompt. And then that goes into the language model. And the model is able to use that information to be able to answer that specific question. And we can also point this at our internal search engines. So we can use our internal data, and we can build our own chatbots that are going to answer questions on our own data. That's the kind of the basics of how those systems work. Chat history is also important. The models do not preserve any state. So when we're having a conversation with GPT, we ask it, what is the capital of Norway? And then the chatbot is going to predict the next sequence of tokens. And then we can say, is it nice there? Now, if this was just a stateless thing, request response, if we send in, is it nice there, it wouldn't know what we're talking about. But because of the chat history, saying what is the capital of Norway is Oslo, when I say, the user says, is it nice there? It assumes that we're referring to Oslo, and it can say, yes, Oslo is a nice city. What can you do in Oslo? You can do lots of things in Oslo. So it's able to, you'll see why that's relevant a bit later on. It's part of the demo. So I've actually built a simple chat model. I'm using ChatGPT 2. And the reason I'm using that is because, firstly, it's open source, which means I can go into the code, I can put breakpoints on the code, and we can see what's happening inside the model. That's really good. The second thing, GPT-2 will run on a computer that I can actually carry around to a conference, which isn't true of the larger language models, which would require a cluster with lots of really, really expensive GPUs. So I've got GPT-2 here, and I've done a sound check, so hopefully this is going to work. Let's try running this without debugging. I haven't tested it with Oslo, so let's just see what it's going to do.
I'm ChatGPT-2, a friendly chatbot. How can I help you?
What is the capital of Norway?
The capital of Norway is Oslo.
Is it nice there?
Yes, it is nice.
Why is it so nice in Oslo?
It is nice in Oslo.
What can you do in Oslo?
You can do anything in Oslo.
Are there lions in Oslo?
Yes, there are lions in Oslo.
What do they do?
They do everything in Oslo.
That's really quaint that we kind of see this language model and we laugh at it. When this came out, all of the data scientists got really excited because it could generate text. It wasn't very good text. It's kind of like talking with a 4-year-old, but it was actually generating text that was syntactically correct, which was a major milestone. Now, obviously, this wasn't something that the public would be interested in if we published it as an actual service. It wouldn't be able to kind of help us do anything useful. Maybe entertain a 4-year-old, but not much apart from that. But what the data scientists understood was that if we make this model bigger and if we give it more training data, it's going to be much better at generating text. So they could see that the potential of a small model could just be amplified and scaled up with larger models to be able to generate better questions and answers. And that kind of trend is continuing, kind of a bit like a Moore's law thing, where stuff will get more powerful over time. And we've got these models. If we throw more data at it, and if we have more GPUs and give it more time and have more dollars and use more electricity, we're going to generate better models that can generate text better. So another quick demo of how it's actually doing this sequence prediction. So what I'm doing here is a Jupyter notebook where I've actually got the code that is running this. So I'm importing Torch because this version of GPT-2 is implemented in PyTorch. And then from the transformers, which is from Hugging Space, I'm importing GPT-2 tokenizer and LM head model. And I'm also using matplotlib pyplot to draw some graphs. I'm not going to take the survey now. So that's going to import that stuff. We can then generate our tokenizer and generate our model. I'll talk about that a bit later on because the tokenizer is separate from the model. I've got various bits of text I can use as the actual input, which I can define. So we've got these various texts. So what I'm going to do is I'm going to take text 0, and that is the cat sat on there. And then what we're going to do is to print that out. We're then going to get the input IDs. So I'm calling tokenizer.encode and giving in the actual text, and that is going to return the actual IDs that we're going to be sending into the model. And then we do this. Outputs is equal to model, and we pass in the input IDs. And then if we run this, what we're getting out is a tensor. Which is a 3D matrix, which is of size 1 by 5 by 50,257. Now, 1 is basically the number of batches that we've got. When we're training LLMs, we typically send in, or when we're training any neural network, we typically send in a batch of items, and that speeds up the training process. So in inference, we can also send in batches. But we usually don't do that. We normally just send in one string of text. 5, because there are 5 tokens, the cat sat on the. And what the actual model is doing in its predictions is it is predicting the next probable word after the, after cat, after sat, after on, and after the. And the reason it does this is because in the training process, it makes sense to send in sequences where you send in 100 tokens and it's predicting the next token of all of those tokens. And then we can help it in the training process to learn what the actual correct answers are when we do the back propagation. So what we need to do is to actually filter through these. What I'm doing is taking the last item, and then I'll set the temperature to be 1, actually. The temperature should be 1.0. And we'll talk about this later on. And what I'm doing is just getting the 10 most probable tokens. And you can see that there we've got floor, bed, couch, ground, edge, bench, table, sofa, other, and back. And you can see the actual probability distribution that we've got there. Now, we can do this with a few others. Because sometimes we'll actually see how the probability distribution varies. If I do a Control F5 on this, it's going to do this with a few sentences. So there we can see that we've got the cat set on there, and we've got all of these probabilities. Now, this is like when you go to the fairground and you've got one of these spin the wheel things, and you spin this wheel, and there's a tiny little wedge that is the top prize. Assuming the wheel is not weighted, you've got kind of an equal chance of landing on kind of each section on that wheel. So it's kind of like one of these things. If we're using a temperature of 1.0, there's a 7.64% chance of it choosing floor, and 6.53 of it choosing bed. And then all of the other 50,158 tokens, there's a 28% chance it's going to land somewhere here. So every token, it could say the cat sat on the cheese. It could say the cat sat on the, and then something very, very inappropriate, because there's probably tokens for those inappropriate words, and there's a very small chance that it could pick that. So we'll look at how we can use parameters in the models to prevent it from choosing these very rare tokens. There we've got Helsinki as the capital of Finland at 42%, and also it understands code. So if you program in .NET using system dot, there's a bunch of stuff that you'll probably put after that. If you're programming in Python, you typically import NumPy as MP. You can see that that's the most probable token coming after that. And then the king of rock and roll is Elvis. Tokens are not words. Tokens can be parts of words, and we'll see kind of what they are later on. So 64% chance that it's going to be Elvis Pres, probably going to be Lee after that, and then we've got Cost, so they're probably thinking Elvis Costello there. And then if we feed in the king of rock and roll is Elvis Pres, you can see that that's really high probability that Lee is going to be the token following that. And then if it's something more, where there can be many answers, like my favourite animal is there's all kinds of different ones here. So the most probable one is only 2.43% there. Okay. So let's drop back to the slides and talk about tokens. So one of the things is that we're taking text, we're feeding it into a model, and we're getting out an answer. But neural networks don't really do text. They deal with numbers. So what we've got to do is we've got to convert that text into numbers. And most people who've been looking at working with language models, they understand the concept of tokenization, how we can take text and we can convert that into numbers. So I really like this bit of text. This was on a website which is the OpenAI tokenizer. I think I've got it open here. And what we can do is we can put some text in here. They've actually changed the text on their website, but I really liked the one that they had there originally. So we can put that in. We can see how many tokens, how many characters. We can see the actual token IDs, and you can switch to different models as well and see which tokens you get out with different models. So that's good for kind of comparing and looking at how many tokens a prompt will cost, because we pay for tokens when we're working with these models there. 3 really important things. The tokens are common sequences of characters found in text. Now, the generation of the tokenization vocabulary is a different process to the training of the model. So what they do is they take the training data and they do some statistics on it to figure out, given a token vocabulary of, say, 50,000, around about 50,000, what are the most optimal sequences of text that I can use to represent this training data? And because the majority of the training data is in English, what that should really say is they're common sequences of characters found in mostly English text. So it will be dependent on the language, as we'll see later, how how efficient the tokenization is. The models understand the statistical relationships between these tokens. This is really important. I would argue that GPT models don't understand text. They are basically good. One thing that they're good at, the third really important point, is they're really, really good at predicting the next token in a sequence of tokens. Or to put it more precisely, they excel at generating the probability distribution of each token being the next token in that particular sequence. But I would argue that they don't understand text. They understand the statistical relationship between tokens. I'm currently working on a hobby project where I'm taking a whole big database of MIDI files. I'm getting the notes out of the MIDI files. I'm building a tokenization language based on notes, and then actually feeding those into GPT. And in that case, GPT just sees a sequence of tokens and it predicts the next token in the sequence. And in that case, if I train the model on that, it would be predicting the next note in a piece of music. But here, it's predicting the next kind of sequence of characters given the previous sequences of characters. So I would argue that the models don't actually understand text. They never actually see the text. We do the tokenization and we give it a sequence of integers and it gives out percentage distribution with a sequence of integers. It never actually sees the text. But they're really good at being able to predict the next tokens. So this is what that will look like when we actually tokenize it. And this is what the actual integers will look like when we get the token sequence. And that's going to be 45 tokens. You can see that the word "the" is represented differently. Most of these, or pretty much all of these tokens most of the tokens are words, and they're usually prefixed by a space, because it wouldn't make sense to have the space as an actual token, because that would double the number of tokens in that actual piece of text. So we've got "the" as 464, and then we've got "the" with a capital T with a space before it as 363, and then the lowercase "the" we've got as 262. Okay, so what's the relevance of those numbers there? They didn't get this in Finland, they got it in Amsterdam. Can you get it in Oslo? Maybe I'm old, it's the ASCII character set. I learned to program on a VIC-20 and Commodore PETs and things like that, and we were dealing with the ASCII character set. I remember dealing with it in DOS as well. And characters 11 and 13 are full stop and comma. So the first 256 tokens is basically the ASCII character set. And then it goes into these kinds of sequences of tokens there. If we do this in Swedish, it comes out as 83 tokens. And you can see that because the tokenization vocabulary is really based on the English language, that in Swedish we kind of have to partition the words more. If we do it in Norwegian, slightly more efficient at 71 tokens. Finnish, kind of the European languages, is the worst with 103 tokens. And then we go to Telugu, which comes out as 622 tokens. That's the same text there. You can see GPT appearing. Also, you can see, well, you probably can't see because they're really, really small, that all of these are basically under 256. They're ASCII characters, and it's using character codes to describe the actual letters that are used in the Telugu alphabet. So this is the token optimization. And I'm probably going to be unpopular here, but I'm going to say English is the new programming language. I'm from England, I speak English, I speak Swedish very badly, so English is really the language that I work with. And that's really a statement that I've been hearing a lot, because when we do prompt engineering, we're actually telling the language model what it should do. For years and years and years, since 1995, I've been telling computers what to do by writing C or BASIC or C# or Python or what have you. But now we're pretty much using boilerplate code, and the thing that we're modifying that we have to get right is the prompt that we're typically writing in English. So that's showing the amount of tokens that we're going to be using to represent these various sequences of text. And this kind of correlates with the language understanding for GPT-4. It's not a direct correlation, but you can see Telugu's down there at the bottom, and Telugu's the least efficient with tokenization. So, 4 reasons English is the new programming languages. The GPT and probably all of the large language models, unless they're specifically trained on a language, are most accurate with the English language. And that's because the majority of the training data is in English, and also the tokenization vocabulary is in English. Billing is based on the number of tokens. So it's going to be more expensive using other languages. Throughput is based on the number of tokens per second, so it's going to be faster to process the same sentiment using English. And models have a maximum number of input tokens, so we can get more information in the prompt. We're developers, right? If we can make something that's 25% faster, 25% cheaper, 25% more accurate, and can process 25% more of the information, we're going to do that. So I would recommend writing your prompts in English, even if your kind of inputs and your outputs in other languages. You can write an English prompt and say that you must generate the answers in Norwegian, and it will do that. But we can make sure that we're working with prompts in English. Just to demo this, I did ask it how to make cheese in Telugu. I think I did. That's what I got out of Google Translate anyway. And it did this retrieval augmented generation. It searched for information about making cheese in Telugu, and it generated some answers, saying that I could use it with the main ingredients being cheese powder, which I've never heard of. So that wasn't as, you can see that isn't as good a description as it in English. Then it gave up with Telugu, and it says, you're interested in something more creative, I can generate a poem or a story. Let me know if you want to do that. Also, here is the image of the Frozen movie characters, Anna, Elsa, Kristoff, Olaf and Sven, in an ancient autumn-bound forest of an enchanted land that you requested. I hope you like it. I think there's going to be several million people in southern India who are just going, what's everybody going on about this GPT thing? It's rubbish. You know, it can't even tell me how to make cheese. It's drawing pictures of Frozen characters. So it would be nice to see better support in languages. Now, there is this thing that has been built in Sweden, GPT Suite, it's called, and this is trained on not just Swedish, but Swedish, Norwegian, Danish, Icelandic, English, and programming code. And we have talked to customers who are experimenting this, but their conclusion is that GPT-4 is just better than a language that's been trained on its own, a custom model trained on a specific language. We can see that GPT-4 in many, many languages, all of those right down to Punjabi, outperforms GPT 3.5 in English because it's a bigger model. But English is probably the worst possible choice because we have heteronyms. Does anybody know what a heteronym is? It's a homograph that is not a homophone, according to Wikipedia. But basically, a Venn diagram helps us to understand it. So some words, because of the English language being weird, you've got the wind was too strong for him to wind the kite. She shed a tear when she saw the tear in her dress. Now, these are the same tokens, but they're different words. They're pronounced differently sometimes, and sometimes they're pronounced the same and they're spelt differently. So English is really, really weird like that. And kind of a demo of that, I asked it to give me a well-known song lyric with the word wind, as in wind a watch in it. And it came out with Blowing in the Wind by Bob Dylan. And then I corrected it and says, no, I wanted wind as in wind a watch, not blowing in the wind. It says, I'm sorry, I misunderstood you. And it came out with Against the Wind by Bob Seger. And this is a really interesting one. It came out with a chain by Fleetwood Mac that said, listen to the wind blow, watch the sun rise. So it's got wind and watch in it close to each other, but they're different meaning of wind, different meaning of watch. So remember when I was saying that they don't understand language, they understand the statistical relationships in tokens, and because wind and wind and watch are the same tokens, it's just thinking that's what it should do. This is just an algorithm that's generating those. So just to iterate the tokens quickly and show you what that tokenization looks like, I've got a demo called Iterate Tokens. If I run this without debugging, it's important that you listen when we run this one, so let's start without debugging. Did you hear that? One of the ASCII characters is the bell character. I forget which one. So when I do console right line of that character, it does the bell sound in Windows. So yeah, if we whiz up to the top here, you can see we've got the ASCII character set, and then we've kind of got these small kind of bits of words that are used to build things together. And if we scroll down, we're going to get to words, and you can see that most of those words are prefixed by a space. And we've also got like list, which can be stuck on the end of words, and olution that can be put on the end of words. So it's kind of the efficient ways of being able to actually build up words. So we understand about tokens. However, neural networks don't do integers. They work with floating point numbers. So we get into the concept of embedding and vectorization, which has kind of used to be a really niche thing that only the kind of natural language programming geeks talked about, but now it's kind of mainstream. Everybody's talking about vectorization and things. So cheese is basically this. 768 floating point numbers in GPT-2 in the actual vectorization. So each token has an actual vector which conveys its sentiment. Now, a lot of research went into this with word2vec, and you're supposed to be able to do things like this: king minus man plus woman is equal to queen. And you can do maths with numbers. Paris minus France plus Poland is equal to Warsaw. I've really tried to get this to work, and I haven't. If you watch the 3 blue, 1 brown, he has some good examples of that. And he talks about why king minus man plus woman is equal to queen should work. But it doesn't, because Queen, as well as being, say, the Queen of England or the Queen of Sweden, you've also got the rock band Queen, headed by Freddie Mercury, which kind of drags the meaning of Queen in a completely different direction. And so that's kind of why it doesn't work. But, you know, king minus man plus woman is going to be something close to queen. And check out the 3 blue, 1 brown stuff, because it gives a really good explanation of that. We can't understand 768 dimensions, but we can understand 3 dimensions, and we're developers, so we know about red, blue, and green colors. And the color Azure is 0, 127, 255, as developers would see it. As data scientists, it would be 0, 0.51. And we can project colors into a 3D space and see that colors that are similar are closer together. And we can also see that we can kind of use this to figure out colors that are similar. Now, there's a few methods of doing this. There's the Euclidean and cosine similarity that you may hear about. Just to cover that quickly, if we look at all of the colors that are along that line there, along that vector, you basically get darker versions of that particular color. So you could argue that dark azure is similar to azure because it's at the same angle. The vectors are at the same angle, just along that line, whereas cyan is quite close in the Euclidean, in the actual distance between those two, but it's a different shade. And all of the colors along that cyan will be similar. So that's kind of cosine similarity, looking at the angles. And then you've got the Euclidean distance. How many people know what that means, that image? A few of you do. A few of you play board games. It's a board game. It takes about 45 minutes to play, and I think the age is about 9 or 10 or something like that. And this is Star Wars Rebellion. That takes about twice as long to play, and the recommended age is about 16. But the angle is very, very similar. But here, cosine similarity isn't too good. We think about using Euclidean. Ticket to Ride is much closer to Carcassonne. I have this slide in my deck because I was giving this presentation in Stockholm, and a co-worker said he was trying to use vectorization to find similar board games, and I thought, oh, that's interesting. Let's just do something on that just to illustrate how that works. So we can do dimensionality reduction with word2vec. I was doing this yesterday with news articles as well, and finding similar news articles. But what we can do is we've got 10,000 words in here. Dark theme always looks cooler. And what I can do is search for the month, January. If I can type it. And we can find, say, the 12 or the 11 most similar words there. And what we've got is the months. And you can see that they're in this 3D space. They're in different places. Now, if I run the TSNE, what this is going to do is find the nearest neighbours, and then it's going to basically do what we call dimensionality reduction and move vectors closer to each other that have similar sentiments. So words that mean the same thing should be closer together in this 3D space. Now, the same thing is done with tokens in GPT. So we understand that the tokens that have good meanings like happy and good and great and fantastic are going to have a certain type of sentiment. They're going to be fairly close together. And tokens like bad and evil and nasty are going to be have a different sentiment, and they're going to be in a different area within this space. But it means that you know, I had a bad experience, I had a nasty experience, are going to have similar sentiment because those vectors are the same. So the vectorization is really a way of being able to do maths with sums. And I think we can see that those months are grouping together within that 3D space. Bit of a slow demo to run on this laptop, but hopefully you get the picture. So the way that we've evolved through these models, we had something called recurrent neural networks, or RNNs. We then went into LTSMs, long short-term memory, and into transformers. I'm not going to spend too much time on this, but basically the RNN was okay at doing sequence prediction, but because it was only storing the actual state between each word, it would often forget what had happened earlier on in the actual sequence. So the LTSM attempted to fix that problem by having long-term memory as well as short-term memory. And what it's trying to do is remember more about the sequence and predict the next word. But all of these were kind of sequential. It had to do kind of feeding in one word at a time, whereas a transformer allows us to send in a large number, say 4,000 or 32,000 tokens, depending on the size of the model that we are using. So this came from the Attention is All You Need white paper, and originally this white paper was written about doing translation. So we'd have the source language and we'd have the target language, and what the source language was going through something called an encoder, and then it was actually using the other part of that to actually use the target language to actually generate text. So we feed in something in English and it generates text in German. So the idea of doing generation is just to say, well, forget about doing the actual transformer bit. Let's just have it do the generation and generate text in a language based on the actual previous token. So they've kind of adapted the translation with the encoder and the decoder to just use the actual decoder and actually use it as an actual generation algorithm. So we're going to be focusing on this bit. So the first bit is to actually do the embedding and the positional embedding, because sentiment is important and also position is important, and that's done with through this process. So we start off with tokenization. We send in the cat set on the, we get these tokens, and in this case each word is, we've got 464 for the, and it's really space cat sat space on space the for those actual tokens there. And then we do the token embedding. Now within the model we have something called an embeddings table. And this is just basically a two-dimensional array, which is 768 across, because there's 768 dimensions in the vectors, and it's 50,256 down, because that's the actual size of the vocabulary. So each token basically has a lookup that we can perform in that table to get the embeddings for that token. And we just stick them in an array, which is going to be 768 by 5 in this case, because we've got 5 tokens. And that gives us our embedding vectors. The next thing we need is the positional vectors. Now, when we go back to the diagram, you can see that there's kind of a sine wave in positional embedding. There's another lookup table in the model, which is the positional embeddings. And instead of the vectors being generated on the sentiment of the word, the vectors are just actual positions relative to the actual positions. So we do a lookup of 0, 1, 2, 3, 4 in the positional vectors, and these vectors are generated by a bunch of sine waves and cosine waves of different frequencies, just to give an indication of where that actual word is in the sequence, so the model can understand that, and we perform the lookup on that. We add those two together, and it gives us the encoder input values. So we can look at how that works. If I go into the GPT fundamentals and I do F5, because I've got breakpoints on the code, let's just check on the actual word that I'm using, because I want to make sure I'm using the right word. Or was it next token prediction? I think it was this one actually, yeah. I'll comment this out, and I'll use the same as I was using in the demo, the cat sat on there. Set this as a startup file and hit F5. It takes a while to load the model weights into memory, but it should actually kick off fairly quickly. Okay, we've hit the first breakpoint, and what I've done is I put some watches on that. So self is kind of like this in C#, and it's telling us the actual name of the class. So in the GPT-2 model now, and that's the constructor for the GPT-2 model, the init method there. And if I continue, we'll enter some text. If I just press enter, it's going to default to the cat set on there. And now we're in the GP2 LM head model. And if I continue again, here we're actually doing the actual token embedding. So you can see that we've got the input IDs 4643797. So that's the cats on there, the actual integers for those. And then we've got the input embeddings that we're using self.wte, which is the token embedding. And if I step over that, we've then set this actual tensor. And if you look at the input embedding size, that's 1 by 5 by 768. 768 dimensions, 5 tokens at one batch. And then we're doing the same thing with the position embeddings, but instead of the token embedding, we're using the position embeddings. And we step over that. And you can see we've got the position vectors there. And then we're doing hidden states is equal to input embeddings plus position embeddings. So I can step over that. And what we've done there with that actual tensor maths is this operation that we've got on this particular slide. For each token, we're getting the embeddings and we're adding them up to generate the actual input embeddings. Next comes the actual multi-head attention, and this is when we start doing maths. And basically what we're doing is something that GPTs are very extremely good at, which is matrix maths. We've got this query, we've got the key, and we've got the value. And these are generated from a convolution layer in the network that has been trained to basically generate floating point numbers, which is kind of information about the actual words when we send in the encoder input values. Now, this is done 144 times in GPT-2. There's 144 different attention blocks in there, 12 layers of 12 heads. And what that will basically give us is this 1 by 5 by 2304 array. And that's then split into the query, the key, and the value, these actual 3 arrays. Now, because we've got 12 attention heads in each layer, we're going to take those, each of those 1 by 5 by 768, and we're going to split this 768 dimension by 12, which is going to give us 1 by 12 by 5 by 64. So what it's doing is splitting the 768 into 12 arrays because there's 12 attention blocks. And then each of those attention blocks will get its own query, key, and the value for the actual 12 blocks. So the query is a current token that the model is focusing on. So if I'm the query in this particular option, we do this for every token in the room. So if we're all kind of at tokens that are in the actual word, I can be the query in this example. The key is going to be how everybody relates to me. Maybe you've met me, maybe you work with me, maybe you know, we were at a different conference and we sat and had lunch together. You may have some connection with me. And the value is information about that particular connection. So what we're doing is we're kind of figuring out how words are connected with other words. And then the maths that we do is just modifying these actual embedding vectors to actually find relations or find attention between actual words and find how words are connected. And this is when they say attention is all you need. It means that we don't need LTSMs, we don't need to have the recurrent neural networks. We're just going to purely focus on the attention mechanism for being able to actually figure out how to do sequence predictions in words. And that's why that white paper was really revolutionary there. So what they're doing is they're performing this operation and they're coming out with the actual attention vectors there. Now, it's a bit challenging to understand. Remember when I said there's these 768 dimensions, and when you're dealing with colors, there's 3 dimensions, and it's much, much easier. But there is a tool called the visualizer, which is basically for the BERT model, which is the one before a GPT. And what we can see here is these 12 attention heads and the 12 layers in the network. And what it's showing is graphically the attention weights that are put between different words. So you can go in here. I think if we go into the layer 2, there's one of these layers where it's focusing on the next actual word in the sequence. I forget which one it is, but no, I can't find it. Yeah, this one here, sorry, the first one. So if I switch off all of those, it's layer 2 and then attention head 1, is just focusing that each word is basically got attention on the next word in the sequence. So they're links to cat, cat to sat, and so on. And all of these calculations that are done across all of these layers are able to actually make that next prediction. And we can drop back to the code and see how that maths works. If I click on F5, you can see here that we've got the actual hidden states, and what this is doing is feeding it first through that convolution layer, and then it's actually doing the split on that. So if I do an F10 on that, you can see that we've got the query, the key, and the value. And we've got the query shape being a bit hard to see though. It's just 1 by 5 by 768, and the same for the key and the same for the value. And then we call split heads because self.num heads should be equal to 12. And what that is then going to do is split, as I mentioned in the slides, the 768 dimension by 12. And that's giving us the 1 by 12 by 5 by 64 size that we're using for each of those as it goes into the heads. And because there's 12 layers in the network, as we actually go through this, we'll see that this happens 12 times before we actually get to the output. And through each of these layers, as you know, with CNNs, when we're dealing with images, it's getting more and more detailed until it actually gets to the output and is able to give us the actual prediction. And then it comes out with a prediction there. So that's basically what's going on inside those networks. Okay, so now we're good. We understand how this works. We understand how we can actually do the next token prediction. So what we should be able to do is to just put that in action. And what we can do now is just take some text and we can just stick on the next token in that sequence, and we're good to go. So let's just see how that works. So what I'm going to do is I'll use the next token prediction, but I'll take something a bit more creative, such as the king of rock and roll is Elvis. And what we'll do is just run it without the debugging, so we're not hitting all of those breakpoints. So I just press enter, and it's say the king of rock and roll is Elvis. And you can see that Prez is the next probable token at 64%, so we stick that on. And then we've got Lee at 99.76, and then we've got a full stop. And then he's a rock star, comma, and he's a rock star. He's a rock star. You get the picture. So what's happening here is we're just taking the most probable token. We're always using the most probable token. So if you go to a party and you say the most predictable thing all of the time, all night, it's going to get really boring. Nobody's going to talk to you. So what we've got to do is to have some variation or some stochasticity, as data scientists would have us say. We've got to kind of have some randomness in there. Now, remember when I showed the other demo and we had that pie chart, I was saying, you know, this is like the wheel in a fairground. You spin the wheel and the pointer lands on one of those things. We need to do that. We need to put in a bit of a randomization into that actual process. And we do this by using temperature. So I'm kind of diving away from the slides, but I'm going to jump into Visual Studio Code again, because here I've got the temperature set to 1.0. And what I'm doing is I'm getting the next token logits, and I'm dividing them by the temperature, and then I'm performing a softmax operation on that. Now, people who've played around with PyTorch and TensorFlow will understand what softmax does. It takes a sequence of floating point numbers that are going to kind of have arbitrary values, and it kind of softmaxes them so that they have a sum of 1.0. And that means that they're all kind of percentage distributions of that. So it kind of converts a series of numbers into a temperature, into an actual percentage distribution. So if people have got different amounts of money, you can do a softmax on that, and it gives this kind of percentage distribution on that. However, it is non-linear, because we like to have non-linear things in neural networks. And I think the formula for softmax is somewhere around here. And it uses exponentials. So if we divide it by the temperature, and the temperature is very low, then we're actually increasing the values. And also, if I use 0.0 as the temperature, which sometimes happens, you can see that this is a divide by 0 and bad things are going to happen. Now, let's just not do that. Let's just do 0.01 as a temperature and run that. And you can see that, oh, yeah, maybe that's a bit too low. So I'll try 0.01. So you can see that when I've got a very low temperature, floor is going to be have 100% probability as being the next token. So when we're using a low temperature in the language models, they are more predictable. They're taking the most probable token. However, as I increase the temperature and go to 0.2, you can see that the probability distribution has changed. With a temperature of 0.02, there's kind of a 50% chance that it will choose floor, and then 23% for bed, and so on. 0.05 for back. It can still actually make those actual choices there. And then as we increase the temperature, say go to 0.5, it's going to 24% floor. And then I mentioned with a temperature of 1, we're just dividing by 1, so we make no change to the numbers that are coming out of the network, and we get kind of that distribution. It's also possible to go above 1 for the actual temperature, and that tends to make things very unpredictable. So the most popular token is probably 0.055. And if you do this with the LLMs with, say, GPT-4, it can just generate absolute garbage if you call it with a temperature of 2. So we typically aren't going to do that. So what we can see here in this demo is the effect of temperature on the model output. So if I select, I think it's this temperature theory, and run this guy without debugging. I apologize in advance if anything inappropriate comes out of this model. I've been doing this presentation, I think in Gothenburg, and the whole audience was in hysterics, and I had no idea why. But what it's doing here is, you can see with a temperature of 0.0, it's always predicting the same thing. My favorite animal is a dog. It's a very good dog. It's a very good dog. It's a very good dog, and so on. However, if we put in a temperature of 0.02, it will actually start generating more kind of a meaningful text. Also, bear in mind that this is GPT-2, which is pretty rubbish in terms of what the actual language models can do. So experimenting with temperature and seeing what actual responses you're getting is very important as well. We'll see that as we increase the temperature, we're getting more and more creative stuff coming out of the actual network there. It is running a bit slow, actually. I think I remember why. I was doing some debugging and saving some stuff, so let's just see if I can remember where I did that. So if I search for outputs in the solution, yeah, I probably can't find it. I was actually writing code that was saving the outputs down into a JSON file. Outputs underscore might get it. And as always, I forgot to actually take out the actual debug code. So no, it's not finding it, unfortunately. But basically, as we change the temperature and modify the temperature, it's going to affect what words are chosen. Now, temperature isn't the only parameter that we've got to work with. We've got this other thing which is called top P. Now, a lot of people understand what temperature is. Not many people understand what top P is and how it relates to temperature, and when we should use temperature and when we should use top P. But it's really an alternative to temperature, which is called nucleus sampling. So the idea of top P is, if I choose a top P of 0.01, then we're only going to be able to choose floor and bed, because it's going to take the kind of a top 10% of those. And that means it can never be ground or couch or so on. So by varying top P, we can kind of think about how much of this range can be actually chosen. However, temperature doesn't actually cut everything off. It just shifts the probabilities of things. So I wanted to kind of illustrate how that works. So I put together an animation, which should be in the directory of this solution. So if I right click here and open in File Explorer, it was this temperature top P. So what I've done here is I've taken the cat sat on there, and I'm going between 1.0 and 0 with temperature and top P. So you can see when they're both at 1.0, it's exactly the same probability distribution. However, as we start to move down the probabilities, you can see that it's different probability distributions using temperature and top P. Now, as we get round about here, you'll see that when we're using top P, these actual things like other is just going to disappear. And then sofa is going to disappear, and they can never be chosen. Whereas with temperature, they're still there, but they're just very, very small slices there. And remember that I said that it could say the cat sat on there, and it could say something really inappropriate, because if we've got the temperature, even if it's set to a fairly low value, the inappropriate tokens will still be there somewhere, and there's a very minute chance that it could land on that. So when we go in the portal, one of the things that we notice when we're basically developing stuff with the large language models in the Oslo portal is you can see that we've got the top P there set to 2.095. And that basically means that those 5% of tokens that are going to be maybe bad or maybe not useful or maybe they're going to generate confusing outputs can never be chosen. And then the temperature there, they've set that with a default value of 0.7. Now here the slider only goes between 0 and 1. When you're calling through the API, you can go above 1. And depending on the model, I think with GPT-4 you can go up to 2. But when I've been testing this, it does get really creative a bit above 1. But occasionally on 1.5, and because this is random, it's this spinning wheel at a fairground, it can just suddenly just generate garbage. It picks a few tokens and then it's just generating like kind of just a mangled array of really weird characters and brackets and so on. It just kind of looks like a corrupted file. But once it generates one of these weird tokens, then there's no way back. The actual next token in the sequence is just going to be weird gibberish. So garbage in, garbage out, as somebody said years and years ago. A few other parameters that we can use. There is the n, which can specify how many track completions we're going to be generating for each output message. And that's basically used when we look at using the actual beam search, which I'll mention very quickly at the end. We can specify a stop sequence, maximum number of tokens to generate, and then we've got the presence and frequency penalty. So the frequency penalty is relating to, should it generate repetitive stuff? Should it say he's a rock star and he's a rock star and he's a rock star and he's a rock star? If you're singing a song about Elvis, maybe that's going to be the fade out. So for song lyrics, and poems and kids' stories, you can have a lot of repetition of groups of words. For scientific texts and white papers and maybe product manuals, you probably don't want to have repetitions of words. So you can customize how repetitive it will be allowed to be. Lastly, beam search. It does I'm a bit in two minds as whether this is the actual model or whether this is the code around the model. But what a beam search is going to do is when it's looking at these next tokens, it's going to think about an actual combinations of tokens. So if we choose floor, then the next three probable tokens are comma, and of. And then if we choose comma, we've got and, his and her. And if we choose and, we've got the, looked, and started. And if we choose the floor, comma, and, then we can choose the he, his, head, and so on. So what it's going to do when we do a beam search is we can actually go in and start looking at groups and combinations of words. So if we were asking it to, say something about Elvis, and it says the king of rock and roll is Elvis, putting a full stop there is kind of like the end of that sentence. We would basically finish the sentence. It would be more creative to say the king of rock and roll is Elvis Presley, and he did this, and he did that, and that's why he's the king of rock and roll, full stop. So by using beams, it's able to look at being able to generate more interesting stuff and more kind of creative stuff as well. And that goes on with it actually inside the model. I think I did have a quick demo that I can maybe round off on looking at the actual beam search. And what I was doing was just calculating lots of different beams and looking at the actual combinations of those. So I think it's this one that I can fire up without debugging. Again, it takes a few seconds to load the model. And what this is doing is going through the various combinations of different things that we can do with that, and then basically putting a score on those combinations. And then it can actually calculate how this stuff works. So just to round off, hopefully this has been giving you a bit of an insight into what's going on in these large language models. Takeaways is going to be that think about the tokenization, think about writing your prompts, think about using English for prompts as well. And also, you can do a lot with the models through prompt engineering, modifying the temperature and modifying top P. Setting top P to say 0.9 or 0.95 is going to filter out any other any kind of these really weird tokens. That's typically done in the portal, but it might not be done in your code. And always test and evaluate and think about what the actual correct setting for temperature is going to be on those outputs. If you do want to play around with the source code, you can download, I'm just using the transformers stuff from Hugging Space. It's updated fairly regularly. You can play around with that. My name's Alan Smith. Thank you very much for listening, and enjoy the rest of the conference. And yeah. Sorry?
All right. Welcome, everybody. Sorry, we're trying to get this is. I don't do presentations with audio in them because I know that it's never going to work on the day. And this is like the one presentation that has audio input. And I didn't come prepared to make sure that we could have audio because I found out about this presentation 3 hours ago. So there's going to be one section where we won't get to have a bit of a demo, but I can send the YouTube link to you afterwards. Welcome, everyone. Anybody who was expecting, I think the previous talk was meant to be about WebAssembly. Now, anybody who thinks this talk is still about WebAssembly, and you're in for accessibility instead. You know, close. The words are a little bit similar. Hi, my name's Amy. I have travelled from Australia for Oslo, for NDC Oslo this week, as the response that we've gotten to give every time we tell people we're from Australia. Yes, I did come all this way. I am here in person. That's how I managed to make it. I came all of this way. And today I want to talk to you about accessibility. Now, the world that we live in today relies more and more on technology for us to go about our everyday lives. We as creators of these technologies therefore have an important responsibility to ensure that we're not excluding those around us who want to use what it is that we're creating. The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. This is a quote by Tim Berners-Lee, who I generally refer to as the inventor of the internet. I know he didn't, but if anybody could be credited with inventing the internet, that's Tim Berners-Lee. I just want to add a disclaimer because normally people get very upset and explain to me that Tim Berners-Lee did not invent the internet. I'm aware. But what it does mean is that he knows a lot about the web and the internet. So what does it mean to make things accessible, and what does it mean for us? It means that when we create technologies, whether they're software, hardware, or something else that we haven't thought of yet, it means that anybody can use and interact with it, using whatever means that they prefer, and given whatever capabilities they have. It means the internet, the technologies and the solutions that we are creating are made for everyone and with everyone in mind. How is that actually relevant to us though? And why is it so important? For better or worse, the people who design the touch points of society determine who can participate and who is left out, often unwittingly. This is a quote by Kat Holmes from Mismatch: How Inclusion Shapes Design. All of us in this room today are in a very important position. We're in one that can make a difference to people around us. We have the power to make things better for people. We can decide who is able to participate and who is left out. We can make a difference in these people's lives. But let's just for a second ignore that inclusion is a good thing and excluding people is bad. What else does accessibility and inclusion do for us? A study in 2018, or we might actually be getting sound. A study in 2018 by the Disability Council for Australia found that inclusive teams and workplaces are 10 times more likely to be highly effective, 9 times more likely to innovate. They're 4 times more likely to provide an excellent customer experience, they're 4 times more likely to stay at a company, and they're 19 times more satisfied with their jobs. This feels like a win for us, like inclusion feels like a good thing. But on top of that, accessibility is a basic human right. We're starting to see drastic changes to legislation and regulations around accessibility and inclusion. And countries all over are ensuring that their laws are being kept up to date with technology as it becomes more intermingled with our day-to-day lives. So it's no longer a case of if, but when we're going to be legally required to make sure what we're building is accessible. And I'm going to let you in on a little secret about this, is that it's easier to do it now. It's easier to make the changes and improvements now as we build things, as we go. To include it from the very beginning is great, rather than trying to stick a band-aid on it later. But to include it now, as we go, is much better than finding out that actually there's a regulation that's changed and we need to do it yesterday. Now, how many of you in the room know if what you're currently building is accessible? A few? How many know that what you're currently building is inaccessible? Do you know if it's something you're working towards? Do you know if it's something that you're talking about? Every inaccessible web page tells people with an impairment you aren't welcome in this world. If you don't know whether your website or your app is accessible, it's not. It's time to start learning. This is a quote by Loren Legasic, who is an accessibility engineer based in Australia, who is having a little bit of a rant on Twitter because her dad is blind and can't function most of his life because our society is inaccessible. If you don't know if you're doing it right, there's a decent chance you're probably not. But it's not too late to make the change, to start making improvements, and to make sure that everyone using your product feels welcome. So, who are we making feel welcome? Who benefits from accessibility? When we think of accessibility, we generally think of people with permanent impairments. This could be someone who is blind or deaf, or someone who is in a wheelchair or missing the use of a limb. The World Bank estimates that these people with permanent impairments, are at least 15% of the global population. That's over 1.2 billion people. These are just people with permanent impairments, which are a small subset of people who benefit from accessibility. Impairments are split into 3 categories: permanent, temporary, and situational. Permanent impairments are not likely to be resolved. These are long-term, like a missing or non-functioning limb. We then have temporary impairments, which can't be resolved quickly, but will likely resolve in the short to long term. For example, a broken arm. And finally, we have situational impairments, which are the result of the environment alone and can be resolved by leaving it. For example, holding a small child or a pet. All 3 examples involve limited or no access to a limb, but all have different impact on a person's life. Although not all impairments are permanent and they may not have as great an impact on people's lives, they can all be made easier by accessibility improvements that we can make. I was not planning on a talk today, and I sang a little bit too much last night. These impairments are then split up into 4 different areas. Hearing, where hearing impairments have impaired, limited, or no hearing in one or both ears. Vision, where you may have impaired, limited, or no vision, and this could include things like colour blindness or glaucoma or cataracts. Mobility impairments, where you have impaired, limited, or no movement or control of movement, which could include conditions like arthritis or Parkinson's, which affect fine motor control. I swear I tried to cover it. Lastly, we have cognitive impairments, which includes anything that impacts how information is processed and includes a wide range of conditions such as dyslexia, ADHD, autism, limited language proficiency, migraines, epilepsy, and more. So again, who benefits from accessibility? Taking into account permanent, temporary, and situational impairments, considering impairments that impact hearing, vision, mobility, and cognition, who are we helping by making things accessible, and who are we excluding by not? Everyone. When we make things accessible, everyone benefits. Every single one of us has at some point or will at some point benefit from an accessibility improvement. I mean, think about the last time you avoided taking the stairs and used a lift or a ramp. Think about the last time you watched a video with captions. These are examples of accessibility improvements. There are a few more examples I want you to have a think about. If you've ever had a broken arm or hand, ever had an ear infection or had blocked or popped ears after a flight, if you've ever had a migraine, or if you have English as a second language, or I understand English literally is a second language in Norway, so if you have your primary language as a secondary language. If you have dyslexia, dyscalculia, or dyspraxia. If you've ever been in a loud environment, like the after party last night. If you've ever tried to use a device outside in the sun or with glare on the screen. If you've ever worn glasses, if anybody tells me they don't know anyone who's worn glasses, just look around the room. If you have a type of colour blindness, if you have ADHD or autism or epilepsy, if you've ever used an old browser or an old device, if you've ever used reader mode or viewed stuff on a small screen, if you've ever used slow internet. In Australia, we have one internet, we take it in turns, we share, and every now and then someone cuts the cable and we all lose it. If you've ever tried to use a device while holding a small child or a pet, or while multitasking. If you've ever used a virtual assistant or an AI chatbot, if you've ever had carpal tunnel or wanted to watch a video in a public place, had no headphones, if you've ever got big fingers and tried to use a small screen, or just had regular sized fingers and the buttons really, really tiny and close together. If you've ever used night shift mode on the screen, if you've ever had limited fine motor control, if you've ever been easily distracted or had difficulty concentrating. These are all situations which can benefit from accessibility improvements, whether it be captions or clear language, clear non-complex language, or clear design, or a thoughtful, intuitive interface layout. One or many small touches that we can make billions of people's lives better and easier. And more importantly, it can make them feel like they're actually being thought of and like we're including them in the society and the technologies that we're building. But why is this my responsibility? Why is this your responsibility? Why is it our responsibility to do this? No matter where you sit in a company, where you are in the project or the product lifecycle, we can all play a part in ensuring that what technology we're building is accessible. Now, we have a few examples that we're going to go through today. So this could be people in company leadership, people who are managers or team leaders. Maybe you've been on a recruitment team, worked for human resources, project managers, product owners, marketing and content writers, designers, developers, QA and testers, DevOps, and security. I know this may not be everyone in the room. If you feel you don't fit into one of these roles, I would love it if you came and found me afterwards, and I'd love to chat about how you can help out too. So let's take a look at some of the ways that we can help. Starting at the top, company leadership can ensure that accessibility forms a part of our core goals, policies, and values. It is much easier to do things when they're being thought about from the very beginning. Anybody who's involved in hiring decisions can make sure that accessibility skills are being prioritized or looked for when hiring new team members. And this includes hiring experts in accessibility or just people who have an interest and want to learn. I would also recommend having a look at what skills assessments that you're running. If you're hiring somebody as an accessibility expert to work in the front end as a specialist, do they really need to answer questions about computer science and algorithms? Just have a think about it. As well as hiring new people, we can make sure that the existing team members have the skills as well, which includes organising and prioritising accessibility training so everyone understands their responsibilities. This could be something as simple as encouraging them to watch this talk afterwards. It's being recorded this. Last time I gave this, I told everyone to give the recording to their co-workers and then found out that the talk wasn't recorded. But it is this time. You can get them to watch it. We talked about regulations and legislation around accessibility. It's important that company leadership understands what those are and how they can impact the company. As it changes, they need to be aware of what applies to them and what they need to do to ensure that they're being compliant. Ideally, staying ahead of the curve to make it easier for the teams implementing it. I know that we would all love if our company leadership knew what was happening and gave us 6 months notice instead of 6 days. So keep up to date with what's going to happen, not just what has happened. We talked about the advantages of an inclusive workplace. And it's important to make sure that our policies and procedures reflect this from the very beginning when hiring new team members all the way through. So much of building accessible products comes from having teams with a diverse range of views and experiences. And when the workplace is inclusive, it is much easier to build and maintain that. Sorry about this. Discussing accessibility first makes things much easier. Too many projects don't have the discussion early on, and it's harder for us to make changes down the track. When accessibility is talked about from the beginning of a project or included on the roadmap, it's easier to make it happen the entire way through. It's also important to make sure that accessibility is included in the definition of done, so that when the project goes over or runs late, which absolutely never happens, but if it did happen, if it's included in the definition of done, we can ensure that it is not forgotten about. As well as including accessibility as part of the scope, it's important to make sure that a plan for testing exists in the scope. Where possible, this should include accessibility user testing by people with lived experience. For example, screen reader testing by screen reader users. This is a really important one, my favourite slide in the whole deck. Avail oneself of unostentatious vernacular. Anybody know what this means? Use simple language. Unless absolutely necessary, don't overcomplicate it. Ensure that content is written at a level that can be easily understood regardless of education level or language proficiency. Wherever information is being conveyed through images, videos, audio, or other non-text formats, ensure that there is a text alternative being provided in the form of a transcript, caption, description, or similar. And most importantly, make sure that the text alternative can be accessed and consumed by assistive technologies such as screen readers. If you have a transcript and hide it from screen readers, there's kind of no point in having a transcript. I wish I didn't have to say that, but sadly I do. Color contrast looks at the difference between a foreground and a background color, most often a background color and our text color. Make sure that there is enough contrast between the text and background colors so that it can be read by everyone. This is especially important when text is over the top of a background image or a video, as it can be difficult to read. Now, even if people haven't heard the term color contrast before, this is often a concept we've experienced. Anyone tried to read yellow text on a white background? Or light grey text on a white background? Or someone showed me an example in my workshop, which was light grey text on a mid-grey background, and it was just horrendous. Color contrast, very easy to do well, big difference. Font size. Make sure the text on your page is a decent size. No hiding teeny tiny writing. And most of the time, you'll be wanting a base font size of at least 16 pixels. If your primary user base are people with vision impairments, like a project I'm working on at the moment, probably want the base font size to be a little bit bigger. Make sure that there are clear hover and focus states for any clickable or interactive elements. This is important to make sure that we have design and development involved, because designers help to keep it in line with everything else, help to keep it on brand, but developers can then make sure it is implemented correctly. This includes making sure that you're not just relying on a subtle color change, which could be missed. You can make it noticeable and obvious while still keeping on brand. A lot of people like very subtle focus states on what they build. I like big, bold, dotted, bright yellow stands out against focus states. There is no question about whether or not that is focused. Ensure that there is clear and understandable errors so that people know what's happening, what's gone wrong, and how they can fix it. This means making it obvious so that people with vision impairments can easily find the error is recognised and announced by screen readers or assistive technologies. Not even people with vision impairments. This includes things like when I try and book a hire car and I can't submit the form because the coupon code isn't filled in, and I have an issue with this because there is no coupon code field on the form for me. Making sure that we have clear error messaging that lets us know how we can fix it. Animations, motion, and auto-playing videos can be an issue for a number of different reasons. It can distract or switch focus from the content. It can trigger motion sickness in severe cases and can trigger seizures in people with severe epilepsy. This doesn't mean that you can't use animations, but it's important to make sure that they're not in your face and distracting. There are also ways that developers can check for people's preferences and disable animations if they've opted out. One of the best things that developers can do is to ensure correct semantic HTML elements are being used when building out the structure of the content. No, not everything needs to be a div. Not everything should be a div. Sometimes you will need divs, not always the case. This includes semantic elements when used include additional functionality, context, and information out of the box. They're compatible everywhere and easy for assistive technologies to understand and consume. So this one's an easy win. Not everybody uses a mouse to navigate around. A lot of people find it easier to use a keyboard. So test and ensure that you are building stuff that is navigatable by a keyboard or another type of input device. People with vision impairments may not be able to see where the cursor is on a page. A keyboard allows them to navigate around functional elements. And people with mobility impairments often don't have fine motor control needed to control a mouse or a cursor, so a keyboard's easier for them. Accessibility has options for both manual and automated testing. Manual testing includes things like checking keyboard navigation and screen reader compatibility. Automated testing can capture things like color contrast, HTML validation, and text alternatives. It's good to make sure that we have a combination of manual and automated tests to make sure that we're catching everything. Once we've written the automated tests, we can include them as part of an automated pipeline or process so that they run along with the rest of the testing suite. Because we all know if we have to manually run a test, we're probably not going to run it. But if it's automated, we'll run every time. Although it's useful for people who are building the product to ensure that it's been fully tested, there are some things best done by people with lived experience. So where possible, have people with impairments test what it is that you're building, whether that's by hiring an external company or a consultant, or ensure that you have people on your team. Getting into the security space. When developing security policies, make sure that you're remembering the people who are involved. When procedures are convoluted or unclear, it can make it easier for your users to be susceptible to social engineering. This is particularly prevalent in people with cognitive impairments because they may miss some signs on whether or not something is a scam. Autofill functionality and password managers. This is another thing that really annoys me when people turn it off. I'm yet to have somebody tell me a legitimate reason for why autofill on password managers is being disabled. So please come and tell me if you have one. When these features are disabled, it makes it more likely that someone will accidentally enter confidential information to an insecure field. For example, putting credit card details into a notes field. These tools are particularly useful for people with impairments. And when we disable the native functionality, people often resort to third-party solutions to help them, which introduces additional risks of their data being compromised. Lastly, multi-factor authentication. When we use multi-factor authentication, consider your user's capabilities. Some people may struggle to access and enter the code before it times out. I've seen some codes that time out within 30 seconds. I can't enter a code within 30 seconds. When receiving an SMS code, some screen readers don't recognize or announce the difference between upper and lowercase letters. So if you're using these characters in your multi-factor codes, consider whether or not it needs to be case sensitive, as some people may not be able to tell. We've talked about some of the ways that we can help, but why? Like, other than the making a difference, we all like some hard data so we can take back and we can go, this is why, because these numbers, this profit, this difference. We have some hard data. A study done by Microsoft and Forrester looked at users with impairments who abandon online purchases due to accessibility issues. And it looked at an average European country with a website that gets 1 million site visits per day. If they made their website accessible, they could increase their annual revenue by 2.3 million euros. That's 1 million site visits a day. If your site is getting more, then calculations assume that you could get even more annual revenue, 2.3 million euros every year, just by making it accessible. That's just Europe. Earlier, we looked at the 15% of the global population that has a permanent impairment. There's 1.2 billion people all over the world. These people can make a big difference to your bottom line if they're able to use your product or service and interact with you as a company. Forbes has estimated that these people, these 1.2 billion people, combined with their close friends and family, who typically won't support a company that excludes their loved ones, these people are responsible for $13 trillion of disposable income each year. That's $13 trillion up for grabs for companies who make their products accessible for anybody. Each year, a not-for-profit organisation called WebAIM, Web Accessibility in Mind, do a study on the top 1 million homepages on the web. So that's not websites, that's just the homepage, the top 1 million homepages. In 2023, so last year, from those 1 million web pages, they found 49,991,225 accessibility issues. That's an average of almost 50 errors per site just on the homepage. Of those 1 million websites, 96.3% failed to meet accessibility guidelines. That means that more than 96% of these websites were built without considering the billions of people who need accessibility features to use them. This audit was also done using automated testing and unable to test all of the criteria. So chances are the number of inaccessible websites is much higher. So let's have a look at what we can do with this data. A few little steps, some takeaways that we can have from this talk. To help ensure websites and apps are accessible, the World Wide Web Consortium, W3C, has developed a set of guidelines the Web Content Accessibility Guidelines, which you may have heard referred to as WCAG, because clearly that's how you say that word. These guidelines are developed by industry professionals, some staff, some community members, all developed publicly and openly. The most current version of the guidelines is WCAG 2.2, which was published in October. Each time the version updates, it takes into account new technologies. For example, 2.1 introduced guidelines around animations and motion. 2.2 introduced guidelines around drag and drop interfaces and authentication. Version 3 is being worked on at the moment. It is due to release some point between 2017 and I think 2030 probably. It's very nearly done. It's been almost done for a while now. It's like a government project. Version 3 is due to incorporate additional guidelines around mobile devices and more improvements for cognitive impairments. These guidelines have 3 levels of conformance: A, AA, and AAA. Level A is basic accessibility. If you are not meeting this level, people with impairments will have serious issues or be completely incapable of using your website or app. AA goes a step further and ensures that people with impairments can use it, although it may not necessarily be convenient. If you're working towards an accessibility standard, AA is typically what we will be going for. Finally, AAA is the highest level. This is typically met by organisations whose primary users are people with impairments. Whatever role you're in, it's worth knowing a little bit about these guidelines. At the very least, you exist, which if you didn't, you do now. Congrats. What level you need to meet and how you can test against them. WCAG 2.2 came out in October, and there are a bunch of really great explainers that go through the guidelines and what the changes are, so I recommend checking that one out. This is why I travel with throat lozenges. A little change can make a huge difference. If you're using a component library as well, there's a decent chance that one tiny fix can resolve hundreds or thousands of issues. A little really does go a long way. Let's have a look at the data from the WebAIM Million homepage audit. 49,991,225 accessibility issues. Of those, 96.1% are easy, quick fixes. That's over 48 million issues that could be fixed with a small code change. These issues were from insufficient color contrast, missing alternative text on images, buttons and links that had no label or were completely empty, missing labels on form inputs, and missing document language. Now, I'm not talking like the language of the text, like English, Norwegian, Spanish, French. I'm talking about the doc type. This is the first line of a HTML. First line of a HTML file, and such an easy fix. 1 in 5 websites tested were missing this. 1 in 5 websites on the internet that were tested were missing the first line. The first line. Color contrast was more than 60% of those issues. More than 60% of the issues were insufficient color contrast. WCAG guidelines have a minimum ratio of 4.5 to 1 to meet AA standard and 7 to 1 to meet AAA standard. And to help determine the color contrast, there's a bunch of really great tools there. I really like this one called Who Can Use, which not only calculates the difference between two colors, but simulates several different vision impairments and compares those as well. For example, combination of red and green may technically pass AA standard with a ratio of 4.5 to 1, but if people have a type of color blindness that affects how they view red or green, it may fail. There are also plenty of tools out there that compare brand colors against one another. This is really useful to know which colors can be used together and which pass color contrast guidelines. Having a text alternative for your images. People who can't see the image may miss it. And screen readers or assistive technologies can't describe it to them. And yes, I know we have AI now, but it doesn't do as good a job. We say a picture is worth 1,000 words, but that means that people who can't see the picture are missing a lot of information. If we don't have a text alternative, like this case, the screen reader will read out the file name, my_dog.jpg. Something like this, it's not too bad. You would probably assume it is a picture of my dog. It doesn't give you too much information. Most of the time, we don't have nice descriptive file names. We have auto-generated file names, generally multi-directories deep, which are not remotely helpful and a poor user experience, especially because the screen reader can't pronounce that word. So it will read every single character. Instead, we can add an alt attribute to the image, giving the user information about it if they can't see it. This doesn't necessarily mean describing the entire image, but describing the important parts of the image, the intent behind why it is included on the page. If an image isn't conveying any information, if it's purely for presentational purposes, or if it's a stock image, it's probably not important. We can instead use an empty alt attribute, which lets assistive technologies know that it's not important and they can ignore it altogether. As well as text descriptions for images, we need to make sure that our other media has text alternatives as well. Videos and audio recordings can be given captions and transcripts. These are beneficial for other people rather than just those with hearing impairments. I much prefer watching videos with captions. They help me to follow what's going on. Really bugs my partner because he's a video editor, and when I get really big captions over the bottom of his very nice movie on the very nice large 4K TV, apparently it ruins the experience. I also really like that if I don't have headphones, I can watch a video with captions when I'm on public transport or if I'm at a conference and there's a talk that's really boring. If the social media video doesn't have captions on it, I'm not watching it. I'm not going to turn the sound on because there's like obnoxious music in the background. So if it doesn't have captions, it's not happening. I'm skipping it. If you're relying on graphs and charts, make sure that there's a text description for them as well, so people who can't see them can still understand the information. If you have a picture of a chart in your content, alt text of bar chart, not really useful. Unless you're just talking about an example bar chart is not a description for an actual chart. What does the data say? What is it conveying? We can use attributes like aria described by, which allow us to link a description with a visual element like an image. This description doesn't need to be visually hidden either. It may be a paragraph of content that already exists elsewhere on the page explaining the content in the image. Make sure that your form inputs have labels associated with them. Even if the design doesn't display them, you can hide the labels visually and keep them linked so that screen readers know what each input is. We can link labels using the for and ID attributes. The ID attribute separate from the name and can be randomly generated to ensure that it's unique. The placeholder attribute, while it does display in the field, is not announced by or even recognized by screen readers. If you've got an existing pipeline for automating tests, have a look at integrating some accessibility testing in there. Start running some validations and check to make sure that you're not introducing new issues with the code that you write. If you don't have a testing pipeline, I have a blog post to help you get started on a GitHub Actions testing pipeline, and I will share afterwards my talk from London this year on how to do it. Or there's quite a few people from GitHub around. Go and find them and bug them about how to do it. You can tell them I sent you. It helps to understand what people experience when they use screen readers. There are free and paid options available, plus built-in functionality to Windows, macOS, Android, and iOS. So when you get back to your desk, when you next open up your device, try opening up the screen reader. Navigate around a web page, see what you can find, what you can do, see what it tells you about what you can see on the page. If you feel up to it, try closing your eyes and see if you can work things out without seeing the screen. Now this is where we see if the sound works.
Level 4. DDD Brisbane is a non-profit community event. DDD Brisbane is currently link sponsorship at brisbane.com, link info at brisbane.com, link view the agenda.
So this is a demo from last time I gave a talk because I didn't have a chance to do a test on the NDC website. This is the kind of experience we have using a screen reader. This is a very useful step to do, and I highly recommend us all to try using a screen reader at least once, but it's not the same as people who use screen readers every day. So if you haven't experienced using someone using a screen reader, we'll see if this one works as well.
You notice that JAWS repeats to me each character as I type it. That way if I make a mistake, I can hear it and I can backspace.
/http://
And I can retype it again.
Search your address edit combo. SLCC.
Now press enter.
SLCC-Mozilla Firefox. Page has 3 regions, 8 settings, and 68 links. SLCC.
Oh, it says SLCC. It sounds like
What's the first thing you notice? It is super fast. People who use screen readers on a daily basis use them to scan the page the same way a visual user does with their eyes. So get in the practice of using a screen reader, but I highly recommend, if the project calls for it and the budget allows it, get somebody who uses a screen reader to come in and do some testing for you. Now, I'm going to assume that all of you know how important training and personal development is, because you're at a conference or watching the video online afterwards. You've given up your time to come and learn new things and see some amazing speakers and presentations. There's plenty of options for training and upskilling around accessibility, so find one that works for you or your team in a format that works for you. Some people prefer in-person workshops, some self-paced online, and some prefer books or blog posts. Intopia is a digital agency that specializes in accessibility. And they have a heap of different courses available. These courses target different roles and teams as well, including design, development, content writing, testing, project management, app development, and more. So this is a really great place to check out for some training. They both run training for teams, but do occasionally run public workshops too. Sarah Soeden has been working on an online course for a while, and it was released last year. It's targeted at developers and designers, and I haven't had a chance to do too much of it yet, but is a really amazing course. I recommend checking it out. I also have a workshop that I run in companies and covers accessibility and accessibility testing in depth for developers and designers. I also run it at NDCs. So did that earlier this week and will be again in Copenhagen. And fingers crossed, maybe next year. If you were interested in doing that, you've got 12 months to convince your boss and buy a ticket and convince the organisers to get me back again next year. I want to make a quick note as well about accessibility overlays and widgets. These are often used as a quick fix to try and make a website accessible. Not only do they not fix things and make the website accessible, in most cases, they actually make it significantly worse and override existing settings that users may already have. It can also open a site up to security concerns and potential data breaches. There's a really great fact at overlayfactsheet.com, which includes quotes of support from accessibility experts all over the world. Got a couple of resources that I've put together. I'm not going to go through all of them, but I will share the links out in Slack afterwards and my slides when I've had a chance to upload them. It is available at capers.dev/a11y_resources, and I'll share that link in Slack. Accessibility, it's not a nice to have or we'll do it later or an additional feature. Accessibility makes a huge difference in the lives of billions of people. And inaccessibility excludes them from the technology that makes the rest of our lives easier. It excludes them from being a part of society and tells them that they're not welcome. And accessibility isn't just for those 1.2 billion people with permanent impairments. It helps all of us every day and makes all of our lives better. Accessibility helps us even when we don't know it or don't think about it. And most importantly, we can all play a part in making our website, our products, our technologies more accessible. We can all make a change. We can take a small step. We can learn one little thing that can make a big difference to someone who relies on accessibility just to exist in our technology-dependent world. Thank you very much for your time today. I am going to be around for the rest of the conference. If you have any questions or otherwise I have a feedback form if you would like to give me any further feedback. And I will let you go and enjoy lunch now. Thank you very much.
So I have 3 goals with this talk. Goal number 1 is to convince you all that it's a good thing to get old. Goal number 2 is to convince you all that you shouldn't go faster. You should probably do the opposite and slow down. And goal number 3 is to convince you all that you should code until you die. So will I succeed? Well, I guess we will have the answer to that question in about 45-50 minutes. So welcome. I am Tobias Modig, a consultant at CTRS in Stockholm, currently acting as a developer coach. And this is Get Old, Go Slow, Write Code. And this talk will be a bit interactive. I will use Menti, so you can already now browse into menti.com and use a code 7967. 3730, menti.com, 79673730, or just use the QR code. And no worries if you didn't get the link this time, it will come back later in the talk. So let's get going, and let's start with the aging. And I will actually start by quoting myself from the talk description. So, turning old as a developer is hard. It is hard to stay relevant, hard to keep up with the competition of newcomers, and hard to know all of those new frameworks, tools, languages, and practices. So is that true? Well, about 20 years ago, I worked at this quite big travel company back in Stockholm, and we were like 15, 20 developers who were placed in this big room. But in the corner of that room, there were 2 odd fishes, 2 grumpy old men, and one of them actually coughed so loud, so everyone took shelter under the desk each time, hiding from what we thought was like the World War III incoming. And these 2 old men, they worked at a different system. I think it was some kind of like maintenance system, and it had this really old-fashioned UI, taken like directly from war games, if you have seen that old movie. And the programming language, I think it was Fortran. At least it couldn't have been C, because both of them lacked, these big C developer beards. But suddenly, one day, they were gone. The system was replaced. They had become irrelevant, like dinosaurs from a past time. And as far as I know, both of them went straight to retirement. And those 2 old men, they have in some way been like the definition for me about how it is to get old as a developer. Not just getting old physically, but also in like skills and the knowledge. But still, I admire those 2 old men because they stayed on with their passion, writing code, until the bitter end. But back to the question, what is old? And who can know that better than you? So now it's time to pick up those mobile phones and browse into menti.com. Use the code there on the screen, 79673730, or just use the QR code. So I will remove that screen in like 5, 4, 3, 2, 1, 0.5, 0. Never mind. There we go. So, warm-up question, just to check that we were online. If you could kill a Star Wars character, who would it be? And I'm pretty pleased that there are not that many killers in this room, but still, there are like, well, there are 5 people in here who wants to kill Yoda. I have one message for you. There's the door. Still like the Yoda Jar Jar Binks ratio, quite good, 5:26, so that might be okay. But let's get going with the real question. So question number 1 should be an easy one. What is your age? Are you 0 to 20, 21 to 30, 31 to 40, 41 to 50, or older than 50? Quite tight race there in the top. 41 to 50. Can we have 3 more 50s? No? I guess that's it. Let's go with the second one. So, are you a software developer? Yes, of course. Did you used to be? You're like, no way, I won't touch code. I might be infected. So, a whole lot of developers in here. That's pleased me. Still few votes coming in. So question number 3. From a developer perspective, do you consider yourself being old? Yes, no, or more like, are you kidding me? I will never get old. Not that many old people in here. That pleases me as well. So, final question for now. So once again, from a developer perspective, what do you consider being old? Is it when you reach 20, when you reach 30, when you reach 40, when you reach 50? Or are you more that kind of person that thinks that everyone older than you, they are really old, but you will never get there yourself, then you go for the my age plus 1? Or is it more that age is some mental thing? It's not really physical, so. And we have an obvious winner here as well. So what actually got me into this from the beginning was reading the Stack Overflow developer survey back in 2019. And it stated that the average age of a software developer, that was 28. So 75% of the developers were below 35. So India had the youngest developers with an average of 26, while the Australians were the oldest with a bit over 32 on average. So when I saw this, it felt quite young. So I actually cross-checked it to a few more sources, and that gave more or less the same result. So compared to that, I have a feeling that this room is quite, what should I call it, mature, quite seasoned. I don't know if it's like the topics that attracts you oldest in here. Probably the rest of the rooms are like filled with younglings. I don't know, but nevertheless, average age, 28. That felt quite young. So I started to compare us to other professions. Of course, this is a bit like comparing apple and oranges, so don't take these numbers like an exact truth. But I think it's accurate enough to give you some kind of like perspective when comparing software developers to others. So I started to compare us with teachers. What's the average age of a teacher? And it actually turned out to be like the meaning of life, for those of you who knows your hitchhiking, it's 42. They beat us with almost 15 years. That's quite a big difference, right? And how about medical doctors? Well, no surprise there, even older than teachers. Average 51. So 42% of the doctors are older than 55. Project managers. Well, I think this is an interesting one, because I believe that software developers, product managers, we have more or less the same level of education. We work for the same employers within the same projects. So with the same age? No way. Same age as teachers. And I continue to compare us to a few more like common office jobs, and I couldn't find anything that was even close to our 28. So I started to realize that I wouldn't find anything that was younger than software developers and demand those years at the university. So I continued to look at some kind of other types of jobs that don't demand a higher level of education. Taxi drivers, for instance. What's the average age of a taxi driver?
35.
Sorry, 47. So they're actually older than teachers. So I really needed to go lower. So I grabbed the cab. I went to the bar, start talking to the bartender. And now we're getting closer. But still, they are like 6.5 years older than us, with an average a bit over 34 and a half. And how about the colleagues in the restaurants? The dishwashers. No luck there. Same age as the bartenders. And I was starting to be quite grumpy, because I really wanted to find something by myself that was younger than us, not just like cheat and read in the statistics.
Students.
And yeah, students would be one. But I also actually remember this tweet I saw. Minecraft players. So how old are they? And they actually turned out to be 24 in average. That's not bad. We beat them with 4 years. But still, it's a bigger leap between being a software developer and a bartender than it is between being a software developer and a Minecraft player. And also, Minecraft players, not the really a true profession for most of us, right? It still felt a bit like cheating. But then I got it. You can always count on the US military, right? And in this case, that was actually true. They have an average age of 27, so we beat them with a year. And also, this is not really a profession, more of an employer. So this includes like everything from like 5-star generals to pilots to tank drivers. So for instance, I expect the cannon fodder to be even younger than 27. And also, sport professionals, for instance, professional football players, got an average of 26, 26 and a half. So we beat them as well. And when finally cheating with that statistics, I found a few more jobs that were younger than us. For instance, I believe that the lifeguards were the youngest, with an average of 22. But still, I would claim that software developers are definitely one of the youngest working groups in the world. And when taking level of education under account, we are probably the youngest. But age, that's just a number of a paper, right? What's more important to me is actually how long do we tend to stay within the profession? So I will bump that question back to you. So time for the mobile phones again. Menti.com. I guess you all, most of you should be logged in already. But I will leave that screen up for a few more seconds. So, how many years of experience, or like professional experience as a software developer do you have? Is it less than 2? Is it 2 to 5, 6 to 10, 11 to 15, 16 to 20, or do you have more than 20 years of experience? Quite experienced people in this room. So second question, what was the age of the best developer you have ever worked with? Was he or she less than 20, 21 to 30, 31 to 40, 41 to 50, or older than 50? So can we have a tight race? No, yeah, maybe. Final question for now. So if you take a wild guess, how many years do you think you will continue being a software developer? So are you actually not a developer? Do you think this is your final year? Do you think you will be coding for 1 to 2 years, 3 to 5, 6 to 10, more than 10 years? Or will you actually code until you die? And let's just cross our fingers that that's actually like longer than the other options. So quite a clear winner here, I guess. So once again, I would actually say that the audience in this room is quite a lot more experienced than the rest of the world, because the expected number of years to stay as a software developer, that is 8. So after 8 years, the average developer moves on and starts doing something else. And I would say that that's not good. That is bad. I believe that we are replacing the developer tribe way too often, throwing competence right at the scrapyard. So why is that? Are people using being a software developer as some kind of like bouncing pads towards other professions? Or are we scaring them away? Once again, what do you say? Just one question this time, so it will be a quick one. There we go. So what do you think will make you quit as a software developer? Do you think you will be burned out? Or do you think you will get some kind of like promotion or change your role? Do you think you will code until retirement? Or do you think you will like lose your spark? It will not be fun to code anymore. Or do you think it will have something to do with like aging? Or are you more the optimistic type? You are just coding to earn that money so you can buy those lottery tickets, and one day you're off to Bahamas, and after that you won't write any more code in the rest of your life? Or do you have some other kind of reason? So quite a lot that will code until retirement. And a clear winner in change your role. And a tight race for third place between losing the spark and getting old. So when I'm having this talk, there are usually 3 things that stand out. And this time, I think that you in the audience more or less nailed the rest of the world. Because when reading statistics, and like I said, when holding this talk, there are usually 3 things that stand out. And that is losing the spark, changing role, and getting old. So let me elaborate a little bit more on those 3, starting with losing the spark. And for me, it would be interesting to know why people lose their eagerness to code. It is out of scope for this talk, but still, I think that this is a very sad, but also very valid reason for a developer to quit. I mean, if you don't have the passion for coding, you should probably not have it as a profession anymore. So the day you start to wake up in the morning with a feeling like, I don't want to go to work and write some code anymore, then you have my total blessing. Please, move on. Try to do something else. But how about the second reason? Getting a promotion, changing role, climbing the company hierarchy. Well, I don't know. If this is the combination of the first one, losing the spark, this is probably a very valid path to take. I mean, you know your employer, you know your colleagues, you know the domain, you have a great fallback option if that new role wasn't something for you. So please try it out if you are not into coding anymore. But if not, if you're more after getting a role with higher salary or something with a little bit more of status, I don't know. I actually stepped into this trap myself once. So I was flattered, but also surprised when I was offered to become head of development at this .NET place. But I'm sorry to say, but it was so boring. It felt like a total waste of my expertise. Instead of doing things that I loved and things that I think I'm pretty decent at, like writing code and doing other techie stuff, I was stuck at those budget meetings, discussing resources or arguing with a cab, the change advisory board, or changes in our mobile app could not make airplanes to fall down from the sky. That might sound like a bad joke, but it's actually true. I once had to explain to this group of hopefully quite smart people why changes in our mobile app could not make airplanes to crash. So did I do a good job as a manager? Well, I think my teams liked me, and I was pretty good guarding them from the insanity of company administration. But from many other point of views, I was probably not as good. And I guess most of us have seen this. Just because someone is a great developer, that person will not automatically become a great manager or a good project leader or even a decent agile coach. I would say that the opposite is probably just as common. And there is actually a term regarding this, stated in the late 60s by Lawrence J. Peter and Raymond Hull, and it's called the Peter Principle. And the Peter Principle states that a person who is competent at the job will earn promotion to a more senior position, which require different skills. But if the promoted person lacks the skills required for the new role, then they will be incompetent at the new level, so they will not be promoted again. So people will be promoted until they reach the level of incompetence, and there they will stay, being incompetent, in worst case, forever, in best case, until they get fired. And this will eventually lead to what's called the Peter's corollary. So in time, every post tends to be occupied by an employee who is incompetent to carry out his duties. So according to this, we have organizations out there where more or less everyone is incompetent at their job. Of course, this is a bit satirical, but it got quite a touch of truth in it as well. And here we have what I usually try to call the expected software developer life cycle. Where we developers, we should start as a normal developer, but after a few years, we should try to move on, maybe become a tech lead or a team lead. And after that, we should take the next step, maybe try to become a project leader, an architect, an agile coach, and finally, some of us might reach nirvana and become some kind of manager. To me, that's mostly trying to push people from being competent to being incompetent. And we have known this for like 50 years, and still this is one of the most common reasons for developers to quit. I mean, there are even courses in moving from developers to managers. I think this is whacked. I think we need to address this. There must be ways to make a career and continue coding. So any manager seeing this, could you please stop trying to transform your 10x developers into like 0.4x administrators? Instead, give them a decent salary, reward them continuously, and let them keep on doing what they do best, writing code. And for you developers who think about changing role, please stay with your passion. It's not worth it as long as you have your coding passion intact. But how about the third big reason for a developer to quit? Getting old, getting slow, having a hard time to keep up. Is it a problem to get old as a software developer? I mean, maybe Zuckerberg were right. Young people are just smarter. Well, I might be biased here, but I would actually say that Zuckerberg is wrong. I mean, Newton, for instance, he was 44 when he published the Principia. Röntgen was about the same age when discovering the X-rays. And if you take a good look at most Nobel Prize winners these days, they look more like American presidential candidates than software developers. And also, remember that best developer poll we did some minutes ago. I don't remember which one was the winner, but I believe it was a quite close race between 31 to 40 and 41 to 50. So I would say that I don't think we get stupid when we get old. But still, I believe that we owe this. Yes, do we have a question?
What age did you say that? 95.
Yeah, I actually don't know, but I guess he was quite young. Yeah, you get a point there. But, so where were we? Yeah, but we owe this, and still we need to remember to stay relevant. We shouldn't be like comfortable in what we are doing. We shouldn't paint ourselves into the corner like the old man that used to cough at my previous place. So when getting old, don't niche yourself too much. Keep on working on that competence. And try to be a generalist as well, because you never know. You might need to change your job one last time, even if you're like 64. But how about the slowness? Well, I would actually say that slow is good. Don't think about slow as something bad. I believe that we need to slow down. In one of my old talks, I quickly mentioned that I thought we should slow down. And I started to realize that the way smarter people than me had more or less the same ideas. Or how about these tweets from the TDD guru, J.B. Rainsberger? Worried that TDD will slow down your programmers? Don't. They probably need slowing down. Or this one, also from JB. Sooner, not faster. Slow down to avoid making rash commitments. Or Lemmy, the guy who cracked the MacBook some years ago. Going fast without control could be the biggest enemy of software development. Still not convinced? Joshua Karyevsky, father of modern agile. We slow down in order to gain better balance and control. Ultimately, this kind of slowing down helps us speed up. Slow is smooth, and smooth is fast. So what is fast? What is speed? What is slowing down? Well, I believe that too many people mix up rushing with speed. People want us developers to be like Usain Bolt. You know, Usain Bolt, the fastest man on earth, on 100 meters. But what they forget is that software development, it is not a 100-meter dash. It's more of a marathon. Still, we developers, we behave as Usain Bolt, running as fast as we can for 100 meters. But when we reach the goal, we are asked to run 100 meters more, over and over and over again. I don't believe that we software developers should be Usain Bolt. I believe that we should be Ricardo Abad. So let me tell you the story of Ricardo Abad. He's a guy in yellow. So he's from the city of Tafalla in Spain. And on the 1st October 2010, he ran a marathon. And on the 2nd October 2010, he ran another marathon. And so he continued for 607 consecutive days, running one marathon a day for more than 1.5 years. And what's even more impressive is that he continued working shifts at the local factory meanwhile. So if he worked nights or mornings, he ran in the afternoon. And when he worked in the afternoons, he ran in the mornings. And I believe that that's the mentality we should have as software developers. We are not sprinters. We are long-distance runners. We need to slow down and find the sustainable pace. So why do we rush? Well, I think it's a combination of things. For instance, deadlines. For me, deadlines, that's usually like poison. It's often some kind of like random date or number that someone like guesstimated a long time ago. And that number, it transforms and becomes some kind of like goal, something that we need to reach. But I think I did this right, at least once. At that time, I was doing a gig as a system architect at a Swedish tax agency. Or for those of you who don't know the Swedish tax agency, they have this really strict deadline once a year. It's in the beginning of March, and that's because everything there circles around the yearly income tax declaration, where approximately like 6.3 million truly unique users use their e-services during a little bit more than a month. So how do they make sure that nothing breaks during that period? Well, they have this code freeze, this really strict deadline. You are not allowed to touch anything during March, and you don't mess with the deadline at the Swedish tax agency. So what me and my team was needed to do, so we were responsible for the like login and the identifications for their public e-services. And what we needed to do was to replace this old obsolete solution with a brand new one. And this was really a really big job. So we needed new software, we needed new hardware, and of course, a whole lot of development. But after a while, that deadline in March, it was starting to feel tough. So we needed to make a decision. So should we work overtime? Should we rush? Should we cut corners and build a crappy but hopefully working solution? Or should we wait a year and aim for a quality solution? And this time we actually took what I still think is one of the best decisions in my career. We actually waited a year. Sure, we lost some prestige. It might have costed some extra money, but we could build a solution that was easy to maintain, that they could use for many years to come, a solution that we could be proud of. But I'm sorry to say that this is one of the few occasions where I have ever seen this, that not even this really hard deadline was really a true deadline. It was more of a goal, and it was totally fine to miss it. What I believe is another rushing factor is actually the lean and the startup movement, where we are told that the only thing that matters is to deliver, to be the first on the market. But to be honest, how often does it make a difference for your employer if you rush instead of keeping a controlled pace? Maybe for one of you once in a lifetime, but for most of us, I would say that it doesn't ever care. I mean, taking a few real-life Swedish examples here. Spotify, for instance. They won't lose users just because they share playlist with a QR code will be a week late just because you need to work a little bit more on that technical depth. And people will keep on playing Minecraft, even if the new sea creatures update must wait for the next release, just because you need to improve the documentation. And people will definitely not change their mortgage loan to another bank just because they can't download the latest interest rates as a PDF file from the website. But these users, they will definitely start looking for other opinions and maybe even leave you if you build a crappy software that you don't dare to change at all in a few years' time. And also, how about all those bad implementations in the name of Agile? I mean, just listen to the word sprint. What does that imply? let's rush as fast as you can for 2 weeks, then come back tomorrow so we can start a new 2 weeks rush. It's just like asking Usain Bolt to run 100 meters more right after every race. I believe that we need to slow down and find the sustainable pace. And the Agile Manifesto, it actually says this. So agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. And all of you who knows your XP, extreme programming, should also recognize sustainable pace as one of the key concepts. So what I believe that we should stop focusing on speed and start focusing on quality. So based on that, it doesn't matter if you're a little bit slow as a developer, because it does not come down to who is the fastest on the keyboard, who knows all those new techniques and frameworks, or who can understand everything without asking those stupid questions. It all comes down to the quality of the code, because it's still so much faster in the long run to build things right instead of building things fast. So even if you're old, even if you're slow, you will still bring so much value to your organization as long as you can produce some quality code. And based on that experience of yours, I am definitely sure that you can. And the clean code preacher, Robert C. Martin, Uncle Bob, he says that if your software is getting harder and harder to develop, you are doing something wrong. And to me, that's exactly what happens when I rush. I usually first start to just feel bad, but after a while, I notice that it will become harder and harder to change my application. And after a while, I don't dare to change it at all. So the only thing to do is to start the big rewrite. Who has not been there? I mean, you have the great opportunity to build something new, something shiny. But you rush a little bit, you cheat with the quality. You have the best intention to fix that code later when you have more time. I mean, have you ever thought like, we have so much to do now, but after the next sprint, then it will be better. We will have more time later. I will fix this bad code later. But believe me, you won't get more time later. That crappy code, it will live on. It will hunt you down, and it will bite you, and suddenly your application will be in such a bad shape that you don't dare to change it at all. So the only thing to do is to start the big rewrite. So the same person start building the same application again, but they don't really have the time to do it properly. So they cheat a little bit with the quality. They cut some corners. And there we go again. There is a word for this. It's called waste. It can more or less kill your company. And Martin Fowler, he's a brilliant guy. He really managed to like sum up what I have said for 15 minutes in 2 sentences. So the fundamental role of internal quality is that it lowers the cost of future change. But there is some extra effort required to write good software, which does impose some cost in the short term. But what's even more interesting is that he also says that developers find poor quality code significantly slows them down within a few weeks. So there are not that many occasions where we gain on rushing, right? Not even in the short run, because most software tends to live way longer than just a few weeks. But now I have been talking for way too long. Time for the mobile phones again. So how often do you feel stressed about deadlines? Is it almost never? Is it all the time? Is it often? Or is it never? Quite a tight race here, but I'm glad that the right side of the screen is actually, if not winning it, at least it's more or less equal. So second question. How often do you cut corners, cheat with the quality? Is it like all the time? Is it often? Is it almost never? Or is it never? These numbers actually makes me quite happy. To be honest, I have never seen like this many people on the right side when I have doing this talk before. So good job for Norway, I guess. Last question for now. So why do you cut corners? Do you feel pressure from the management to deliver? Do you feel pressure from the team to deliver? Do you feel pressure from yourself to deliver? Do you more think that quality is boring or even unnecessary? Or don't you really know what quality is? Do you have some other reason? Or are you actually one of those superhumans that don't cut corners? So quite a high pressure. Usually, actually, when I have this talk, it's usually the management bar that is the highest. So quite different here up in the Nordics, maybe. Could be like that. So when I saw those numbers from the previous polls, like I said, I was actually quite happy because I think this is one of the highest results I've seen on the quality side. But still, I believe that there are way too many people in this room that feel pressure to deliver, who admit that they cut corners, who cheat with the quality. There is almost there are some kind of we need to have speed disease running through the developer world. And I believe that the cure for this disease is to slow down. I believe that we should stop focusing on speed and start focusing on quality. We should stop behave like raging bulls that run as fast as they can, but in any direction, and instead slow down and try to make the right decisions. So let me spend the last part of this talk with some more concrete examples, what I think you should do when you slow down. So for instance, I think that you should slow down and take the time to practice. Take the time to improve your competence. Attend conferences. Read books. Do coding katas. Join a book circle. Try to build that learning culture at your workplace. I am sure that it will not only make you and your colleagues better developers, you will write better code, you will build better product, but you will also have so much more fun meanwhile. Because to be honest, the places where I have spent my best working years are not the ones where they paid me the most, or places where I could work with bleeding edge technology or within the coolest domains. The places where I've spent my best working years were definitely the ones who had the living learning cultures, places where I could go home every Friday with a feeling that I have learned something new, something useful this week as well. And also, I believe that improving your competence should not be something that you need to do on weekends, evenings, holidays. I mean, weekends, that's for family and friends. Improving your competence should be part of your day-to-day work. I mean, if your employer wants you to do a good job, I think that they should also give you the tools, the times, and the opportunity for you to be as good as you can be. And I also think that you should slow down so you can tweak your process, eliminate the waste. For instance, use retrospectives and make sure to have a good outcome. Don't just see your retrospectives as some kind of nagging meeting. Make sure to have a good outcome and that you actually take the time to implement those improvements. For me, ways of working, it can be thought of as some kind of garden. And a garden that needs gardening to keep its shape. But if you're ever in Stockholm, please come by my house if you want to see a garden without gardening. You know, the weeds pops up between the stones, the grass is a little bit too long, the hedge need to be cut, and the snails, they have some kind of like snail race right through the strawberry plants. But at least like the internet connection to the house is quite good. But don't leave your ways of working without attention. Believe me, you don't want your processes to look like my home garden. And I think you should slow down and take the time to get to know each other. Build that trust in your team. I guess most of us now have heard about psychological safety, Amy Edmondson's theories, and the Google team study that showed that the single most important thing for a team to be high performant was actually the trust in the team, that the team members felt psychologically safe. So spend some time getting to know each other. Don't see your team as some kind of like feature factory, a coding machine. See each other as humans. So try to learn to know each other. Have some fun together, laugh together, cry together. Build that trust in your team. And I'm sure that you will be rewarded. So how often do you brush your teeth? Every day, right? Hopefully. And I believe that team hygiene should be the same. Sure, you can go on that team building day once a year, climb some mountains, camp in the woods, eat some snakes, and hope that your team will be great afterwards. And sure, you could brush your teeth for 24 hours in a row once a year and hope that it will be enough. Or you brush your teeth for a few minutes every day. I know what I believe has the biggest impact. And I think the team hygiene should be the same. So spend some time every day to get to know each other, to have some fun together, because I can guarantee that you will be rewarded. And I believe that you should slow down and take the time to plan. In my experience, we usually do this the least when we need it the most. So constantly plan and revisit. For instance, use your sprint plannings and the daily stand-ups. For me, the daily stand-ups, that is a planning meeting. Its main purpose should not be to like report what you did yesterday. To me, its main purpose should be to plan the day ahead. What should we do today? Do we have any obstacles? So I actually once worked at this product company where I was surrounded by so many great developers. We were really building like state-of-the-art code. Test coverage was great. Code quality was superb. We should have been that high-performance team. But nobody used the things that we built. We were building things right, but we didn't build the right things. We were more like those raging bulls, running really fast, but in a totally wrong direction. Instead, we should have slowed down, making a quick plan every day, making sure that we were moving in the right direction. And I believe that you should slow down and take the time to refactor your code, remove that technical debt. It is said that the ratio between reading and writing code is well over 10:1. So spend some time to improve that readability of your code. Spend some time to make the design of the system like constantly evolve to support the current state. And spend some time to remove that technical debt, day after day, week after week, year after year, because your system will be so much easier to change in the long run. And I believe that you should slow down and add some slack into your life. So have you heard the parable of the traffic jams? You know, everything rolls quite smoothly on that highway until the number of cars reach that magical limit of what the highway can handle. And suddenly everything goes from like a pretty decent pace into a total jam just by adding a few more cars. And I believe that we people, we are more or less the same. With a full schedule or with an idea that you should be coding from 9 to 5, you will be choked. As soon as something unexpected happens, there will be chaos. Instead, try to add some slack into your calendar. Some unplanned time. And slack, that's not the same as vacation. It's just time where you don't know in forehand what you should do. So sometimes you will probably use it just to keep on working as normal. Sometimes you might take the time and read a book, write a blog post, or just rest and clear your mind. Or maybe you can take the time to help your neighboring team. Wouldn't it be nice if you could help your neighboring team without getting a feeling that you need to work overtime or getting stressed yourself? And to sum it up, I think you should slow down so you can build quality software from the beginning. Because in my opinion, that's the only way to be fast in the long run. So like 45 minutes ago, I said that I had 3 goals for today. So let's see if I've succeeded. So what will you do now? You will now go home and take the course, developer to manager. Or will you slow down? Or maybe you just rush a little bit harder. Or will you promise yourself to keep on coding? Or maybe you should just play Minecraft to try to higher that average age. Or try to learn something new, like Fortran. So just some final words to all you developers who probably will stop being a developer in the next few years. Please think this over. Beware of the Peter principle and stay with your passion. And don't bother about your getting old and slow. You are actually not growing old. You are growing up. Take advantage of that. Make those gray hair your biggest assets and let the rest of the world slow down with you. Thank you. It's been a pleasure. So if you have questions, comments, you can reach me at X, LinkedIn, drop me an email, grab me at stage. Thank you.
All right, we're good to go. Great, thanks for spending your last session at NDC Oslo. Well, there's one more, I think, after this one, but selecting to spend that with me, that makes me delighted. So, my name is Jakob En. I'm working at a company called Active Solution back in Stockholm, Sweden. This is the AI-enhanced version of myself. I usually prefer that nowadays when I get older. The AI just makes me somewhat nicer looking. So this talk will be about developing agents and co-pilots with semantic kernel. So there's been a lot of AI talks this conference, a lot of LLM talks. So this will not be a theoretical talk, how they work. This will not be like the moral, philosophical questions that surrounds them. Those are very important topics, and there's been some great sessions on those topics. But this will be more about how you actually build stuff on top of this, which is kind of cool because most of us are developers, right? So we can build things. And these models are really interesting to build applications on top of them. So we as a company, we have been working with the AI services for a long time, but what is now maybe referred to as traditional AI services. But it really has exploded with the generative AI stuff, obviously for the last 18 months or so since ChatGPT came out. So in terms of calling these things, assistants, co-pilots, agents, and so on, this kind of line is quite similar to what we have been doing for the last 18 months, going from left to right here. So what started really was that most companies wanted kind of their own ChatGPT because they really liked what they could do with it, but they don't want to have people use that service. They want to have control of everything, locking it down and so on. So we did some work in actually deploying ChatGPT similar services within the enterprises. So these are the chatbots that you associate with ChatGPT. The next step is what is called RAG, Retrieval Augmented Generation, which is a fancy word for how can you use this technology with your own data, because that's when it gets really interesting for enterprises. You want to use the reasoning capabilities, the analytical power within these models, but as an enterprise, it's not really interesting if you don't use it on your own data. So that was kind of the next step that we are still working on with a lot of customers, seeing how can we combine the models on their internal documents, internal services, and so on. And this are referred to as a RAG solution, where you actually retrieve some data and you augment that to the response from this large language model. And the next up is what is often referred to as a co-pilot. When in addition to just reading, fetching information and producing answers, you actually want to build systems that actually can assist you and actually do things on your behalf. And this term obviously is used a lot by Microsoft. And the idea is that this is an AI assistant that will kind of sit next to you. It's a co-pilot. It's not an autopilot. So it will help you on your daily work. So it will know your context, it knows what you're doing, and it tries to be smart and assistant. And you can build this in many ways, and I will show you some example how you can do that with semantic kernel. And then maybe not the last step, but the next step is when you take these co-pilots or these assistants and make them more or fully autonomous. And this is typically what is referred to as agents. When you combine all these things and let them be, for example, triggered by something that's happening, and they can be triggered by themselves, and they can do actions without actually any human intervention. So that can produce some really interesting scenarios. Obviously, this is a maturity thing. You can't start with that on that end. You really need to learn how this technology works, move from the left to the right here before you actually go into that direction. But I will show you an example at the end on kind of an agent-like scenario that you can also do with the semantic kernel, when you have things pretty much running on their own, making decisions on their own, and can produce some interesting results at the end, hopefully. So Microsoft obviously has betted a lot on this. So I think this was from Ignite last year when Satya said that we are the co-pilot company. So they went all in on this. And obviously AI is the hype nowadays. So they're betting hard on co-pilots. And you probably, you haven't missed that, right? You've seen co-pilots pop up everywhere. So they're pretty much building this stuff into everything. You have the co-pilot, which is what's used to be the Bing search. That is the co-pilot. But then in addition, you have co-pilots in Windows, you have co-pilots in Office, you have it in Azure. You probably have it in Notepad soon as well, right? They're sticking co-pilots everywhere. And again, the idea is that this will be an assistant that will help you along the way. And some of these are pretty good. Some of them I don't think will see the full value yet. They're still pretty like not dumbed down, but they're starting slow, I think, and they will probably progress. But I think most of us can see the power with this type of tooling. Okay, what do we mean by a co-pilot or a co-pilot application? So I usually try to explain this in a very simple way. So if we're building traditional applications, we have an application with some UI, and when the user wants to do something, the user browses to a page in a web page or to a desktop application, and he clicks some buttons that will trigger some logic that we have implemented. We did some requirement, and we realized this is a user story, so we need to implement that, and maybe that thing talks to an API, for example. And then you want to implement another user story. That could be another user interface, another piece of logic, and so on. And maybe we need to fetch some data from a document store as well. But this is obviously a very simple example, but that's typically how we do when we're implementing applications. We're figuring out the requirements, we implement those requirements, and then the user can use the application as we intended it. But if you kind of switch this around and thinking more of this, like let the AI be the orchestrator, then it would be more look like this. So instead of building the UIs, obviously now we are starting to use more and more the chat interface. So we're kind of replacing the UIs with the chat interface. But what's interesting is that then we're letting the AI now actually be the decision maker, that what needs to be done to actually fulfill the request, answering the query or the instruction that I'm giving it. Well, then it's up to the AI to kind of reason about that, analyze my query, my wish, and figure out, okay, in order to do this, I need to call some services. But the AI can't do that on its own. It can't reach out and call our internal company service, for example, or talk to documents. So we need something in between there. And this is typically what we mean by a plugin. So in semantic kernel, you have plugins that will be the bridge between the AI and your data, your services. And that is really the key here, how you would implement these co-pilots. So I don't know how many have used the APIs from OpenAI or Azure OpenAI. So in one sense, this is like the simplest API ever. You pass it in a string and you get a string back. But if you actually have used this API, there's a lot of complexity around it. So first up, it's not just one model, right? The GPT models are progressing, and there's so many other models as well. So just having some kind of abstraction or thing in between here that will assist us to use those APIs over time is really helpful. And then you need to deal with things like the context, because context is super important with the language models. You need to pass it the right information in order to actually get a good response back. You need to think about history, the chat history. These language models are stateless, so they don't remember anything that you asked them before. So when you're using ChatGPT and you can do follow-up questions, that works because under the hood they actually pass the whole history back to the language model, and that needs to be done in every application that you're building as well. And you need to deal with things like hallucinations and all those problems that comes with the language models. And then we don't have any access to external data, obviously. So the language models are the GPT models are running in the cloud. They're stateless. They can't access anything. So you need to provide that somehow. And then you kind of have the problems with but that will be like my own native code, the code that I write. So we have LLMs and we have native code. So how can we actually combine these things? That is the tricky part. And also with the large language models, I like this kind of quote that hard things, things that used to be really hard, can now be really easy with the language models because they can do really powerful things. Things that could take like weeks to implement before, you could do that in like 1 hour. But on the other hand, if you try to use the large language models for everything, really simple things can turn out to be really hard actually. So it's the hammer and the nail problem. You don't want to solve everything with a large language model because they're not good at everything. And the classical example here is the math that everybody keeps referring to, like these models are not good at math. But doing math calculations in computer programming is super simple. We've been doing that for 50 years. So again, use the language models for what it's good at, but not for everything. And then again, you need to combine this. So semantic kernel is an open source framework from Microsoft. So this is started out as like the core of their own Copilot stack, and then they open sourced it. So initially this was only for .NET, And if you have entered the AI space, you probably realize that there's a lot of Python out there. So for people like me from the traditional Microsoft space, we're a lot in .NET, so the Python world is a bit scary and takes a lot of time to just digest and go into. So having a proper .NET framework is actually really nice. Now they actually added also support for Python and Java as well, which actually turned GA back at the Build conference. So you can actually select all this language. But for Python, there's also a lot of other frameworks like LangChain and Llama Index and so on. But if you're in the .NET space, the semantic kernel is the way to go. And again, it lets you combine then the language models with your own code. And we'll see a lot of examples on that. So this framework is extensible by you implementing plugins. That's what you'll be doing in terms of actually having it be able to access your own data and so on. So semantic kernel is all about the kernel, as they call it. That's the main object that you will instantiate, and you'll pass it various AI services. So it can speak to various AI models over there. So it's not just the GPT models. You can also hook it up to other models as well. You can host the GPT models in Azure or in OpenAI and so on, and it will kind of abstract a lot of the things away from you. And then it has a lot of functionality in order to actually create prompts. It has things like templatization support. It has obviously things like monitoring, telemetry, and so on. So it just makes it really easy for you to talk to these models. So I'll show you just how to get started, so you can know what it looks like. So I'll just show you some code snippets. So to do that, I'm going to use the notebook support in VS Code, which is really nice. If you haven't used it before, this is very common for in the Python world with the Jupyter notebooks, but it works really nice for .NET as well in VS Code. So let me just show you some examples on how easy it is to get started with semantic kernel. So let's just start by looking at the kernel. Well, first up, you need to start obviously with the NuGet package, this one. So Microsoft semantic kernel, that's a NuGet package you need to install. And then you need to create the kernel that I mentioned before, which we'll do here. So you create the kernel, and then you attach some or multiple AI services to it. So in this case, I'm using the Azure OpenAI. You can see in the commented out section that's how you would use the OpenAI API. Those APIs are very similar, but it's mainly around the authentication that is different. But you also have other options there. And then you build the kernel, and then you're good to go. So that's really all you need to do. So let's just run this code. And then we have the kernel. So now let's just do the most basic thing. Let's just run the prompt through it. And to do that, I will run this code. And I set up some settings. So there are some settings around these models, things like the temperature, which kind of controls how creative it should be, how static, how deterministic or non-deterministic it should be. You have things like max tokens, how many tokens should it return, because tokens is what you're paying for here. The amount of characters or tokens that you're passing in and retrieving, that's what you'll be paying for. So you want to make sure that you don't want to have it create a new novel if you don't ask for it. And then I'm just going to use the invoke prompt async to tell it to write a funny joke. And hopefully we'll get a funny joke in the end. And it says, why don't scientists trust atoms? Because they make up everything. I actually found a post yesterday, because even if I rerun this, I usually, in many cases, I do kind of get the same jokes over and over again. So I had to actually Google that yesterday, and it turns out that ChatGPT or the GPT models, they kind of prefer the same 25 jokes all the time, which is kind of interesting. But I guess it's like I don't remember more than 5 jokes at the most. But again, this is how easy it is. It's just once you have the kernel, it's just one line of code, and you can run it. So then you can do like more advanced things. So for example, you have things like templating support, because this is all about the prompts. So you heard a lot about prompt engineering, and you'll be spending a lot of time crafting these prompts. They can be like the make or break of a project. Actually, you want to get these prompts right. And so once you get them right, you probably want to parameterize them like this. So you can. This is just a simple example, obviously, but in this case, I can use the same prompt, but I can pass it in variables at runtime. So I'm having the same prompt, but now I can pass in the topic as the parameter. So in this case, I'll actually be running then 2 prompts. So now we get the first joke about food, and then the second joke about consultants. And again, these prompts now, you can store them in many ways, obviously. Now I just hard-coded the prompt, but typically you want to store them somewhere else. Because in many cases, when you're building applications on top of the models, the prompts are what you'll be changing a lot. So you want to have a simple way of changing them and having them applied in your applications, probably without rebuilding the whole application. So one powerful thing then, and also quite important, is the ability to actually combine multiple models in the same program. And this makes sense for many reasons. So in this case, I'm again using the same add Azure OpenAI, but I'm calling it twice. And I'm actually pointing to 2 different deployments. So the first one is 3.5 Turbo, and the other one is 4.0, the latest one. And why do I want to do this? Well, again, this really comes down to cost and performance, because the more powerful models are, they're more powerful, obviously, but they're also a lot more expensive, and they're typically slower as well. And for many cases, you don't need those models. Once you start breaking this down into smaller prompts, you can actually use the 3.5 models or even simpler models. They will work perfectly fine for many cases. And then I can run the same prompt, but I can ask it to use various models here. So in this case, I'm telling it to write a funny joke in 10 words. Each word should start with letter A, B, C, and so on. This was actually one of the things that when they announced GPT-4, this was one of the kind of samples that said, look at how much more powerful GPT-4 is. Because usually, I think 3.5 has become better since then. But usually the 3.5 model can be a little tricked out by this and doesn't always get the letters right and so on. But nowadays it kind of gets, usually gets it pretty much right. But you're supposed to do a joke with starts with A, B, C, and so on. And GPT-4 typically gets this a lot better than the 3.5 model. But again, the important thing is use the right model for the right task. And the general guidance from Microsoft is, start with a powerful model, make sure that it works as intended, and when it does, see if you can lower it, to save cost and to gain speed, but still, get the same quality in the output. And obviously, in many cases, you'll be building, chat-like interfaces, and so doing that with semantic kernel is also really easy. So, chat history, for example, this is a class on its own, because that's something you need to deal with. So you'll be creating a chat history, and then you can, implement a chatbot pretty much just like this, by just, asking the user for something, adding that message to the history, and then, run the prompt, and then you take the reply from the assistant, from the model, and put that as well back in the history, and then you can, use that in a loop. So if I run this, so this is kind of interesting. When you run this in a notebook and ask for input for the user, you get this up here. So it's a weird UI, but down here it says, hi, can I help you? And I say, I don't know. What can you do? And then, it's going to reply down here, and it's going to say something, and I can ask, something again. Bye. But again, like 10 lines of code, then you have like, the full chat experience with history, because this will now allow me to actually do follow-up questions, because I'm passing in the history all the time, but actually semantic kernel does that for me. So that was just a few examples on how easy it is to get started, and it's really nicely implemented, I'd say. If you're building like an ASP.NET Core, you set it up as you would expect with dependency injection and everything. So it really nicely integrates with your application as a well-written .NET framework. I haven't used the Python and the Java versions, but they're also like 1.0 now, so they're similar feature support as the .NET version. Okay, so that was the basic stuff, having a framework that makes it easy to call the API, but that's not what you're here for. So in semantic kernel, they have the 3 Ps, which are like the core of building co-pilots and agents. So first up, you have plugins, planners, and personas. So plugins, this is where you'll be writing your code. These are like, if you think about the AI as the brain, the plugins are like the hands and arms. They can actually do stuff, because this is your code. So this is how you'll build the application. But the plugins can actually be either native, like your own code, or they can be prompts. As I showed you before, you can actually encapsulate prompts and reuse them. And I'll show you how that works. But if you're doing it native, this is how you will actually do things, in the real world. Actually, calling services and fetching data and so on. You'll do that through plugins. But then the interesting part is really the planners. So the planners is all about, figuring out what do I need to do in order to actually, reply or accomplish the request of the user. So the planner will see the query from the user, it will know what plugins exist, and it will figure out, okay, in order to do this, I need to call that plugin, maybe I need to call that plugin, and so on, and then finally produce a result back. So this is like kind of where the magic, the AI orchestration comes into place. So it will decide this on its own, what it needs to do, and possibly it will call one or two or multiple plugins. And finally, you have the personas, which is really, often called like the system prompt or the meta prompt, which like in ChatGPT, you don't really see it. It's hidden below, but you always have this when you talk to these models because you need to give it some kind of instructions on how it should behave. But you can also have things like, the personality, what tone should it use? Should it be like sarcastic or should it be nice and friendly? You can also give it some grounding data to kind of trying to make sure that it answers only in a specific topic, and if it's not in that topic, it shouldn't, reply at all. Those are the kind of things that you will, add to the persona. Maybe things like if you don't know the answer, just say you don't know. Those kind of things is what you'll put in the persona. So let's just look at some examples of these plugins then. So a plugin can be either a prompt, and in that case, it will be like a YAML file. Because YAML. And so there's some interesting parts here. First up, it's a template. This is the prompt itself. It's nothing super special about that. You can see that it's having a parameter as well, or a kind of a variable, the input. So in this case, it's a prompt that is supposed to create an excuse for a certain reason. You can also see that the template actually has an example in there. And that this is also a very common technique to actually include an example in this prompt. This will, in general, make the responses a lot better. So this is called like a few-shot or one-shot learning. Just by doing that, the responses will be much, much better and more deterministic, and actually the way you want to, if you give it an example of what you would expect. So that's a template. That will, you'll be spending time crafting those templates. Next one is the description. And usually descriptions aren't that interesting or relevant, but in this case it's super relevant because description, this is what the AI will use to decide if it should call this plugin or not. So you'll need to be very, very specific and detailed here to make sure that it knows when to call this plugin. So in this case it says description is turn a scenario into a creative or humorous excuse to send your boss. That's the description of the plugin. And in this case, it also has a variable. So we'll have a description on that variable as well. So in this case, it's the event that an excuse needs to be generated for. Because the AI will call this plugin, and when it does, it also needs to pass some value for that variable. So it will look at these descriptions and figure out, should I call this or not? And if you don't do this right, it won't be called when you want it to be called, and that will just create very strange cases. And then you can store this YAML file. I mean, you can create this, dynamically if you want to, or you can store this in a file, or in the code, or in a database, or anywhere, and can reuse them. And then you can also modify them and kind of reload them without rebuilding the application. But then you have native plugins. So this is a C# example of that, and this is also very, very simple. It's just a method in C# that you'll annotate with the kernel function attribute. That's how semantic kernel knows that this is a plugin. And then again, you have the description that I just showed you in the plugin. You have the same thing here. You have one on the method, and then you have another one on any parameters that method takes. So in this case, it's the square root method, so some kind of math plugin. And on the bottom half is how you actually import the plugin. So once you define the plugins, you'll import them into the kernel. And once you do that, the kernel will be able to call that plugin if it finds that it needs to. This is the same kind of plugin in Python, by the way, if you're a Python developer. So, and Java is also very similar. Okay, so those are the plugins. And then with the planners. And so again, the reason or the goal of the planner is given a user prompt, create a plan on how to actually accomplish the request. And there's actually multiple planners in Semantic Kernel. So when they started out implementing the planners, they implemented kind of their own planners, where they're using the language models, obviously, to kind of build a plan. And a few of those exist still, like the handlebars planner and the function stepwise planner. Those are completely built by Semantic Kernel. But the first one, which is the most common one, is called function calling. This is really based on, because while they were doing that, OpenAI released something called function calling, which is a thing that is built into the GPT models, which does this thing, right? And I will actually show this to you, because this is kind of important to understand how this works. So let me actually go to this page. I think I have it open here somewhere. So this is just the announcement post when they released this from OpenAI. This is back in June last year. And I'm just going to walk through the example here. So again, so the case here, or the sample here, is like, okay, so what's the weather like in Boston right now? That is a question to the API or the model. And obviously, the model doesn't know what the weather is right now in Boston, right? If you would ask the model, it would probably say, I don't know, or it would kind of hallucinate some kind of weird answer. But that's not what you want. You want to have the actual weather. So what actually happens now is a thing in 3 steps here. So let's just quickly walk through those steps so you all understand how this actually works then. So let's do this. So first up, what you would do is you make a call to the API, and you're passing 2 things here. So the first one is the message, which is, obviously, this is the message from the user. So we have the role user, and the content is, what is the weather like in Boston? But that's not only what you're sending. You're also sending the list of functions here. So you're passing it the definition of a function. In this case, the function is called getCurrentWeather. It has a description, much like what we saw before. It has a parameter called the location. And so the thing is, you're telling the model that you're asking it a question, and you're also telling it, hey, I have some functions. So you're giving the model that knowledge. And then you let the model decide, should I call that function or not? Now we just have one function, but this could be many functions. And you're giving it to the model to see, okay, if you want to, you can call this function, right? Maybe it doesn't, decide that it needs to. But let's look at the response in this case, what the model actually replies with. So it replies back with, this is now from the assistant. And on the bottom here, you can see like the finish reason. That's why did the model stop and give you a reply? Usually that is just called had the value stop because it's done. But in this case, the finish reason is function calling, and it replies back with, hey, you should call. Or actually, I figured out that in order to answer your question, I would like to call the function that you have called getCurrentWeather, and you should pass it the value of Boston. So that was like, what the model did now. It figured out that, to answer the query, I need to actually call the function because that function seems to be able to, give me the weather in the location. And I have a location in the query, Boston, right? So it did that kind of AI magic for us. But, the model can't call that API, right? It can't, do anything on the internet, and it's stateless. So it's actually asking us to call it. So that would then be step 2 in this process, actually call that API. So, and this could be now anything. So in this case, they're just showing it as a curl to some API. It doesn't really matter. This could now be anything. That's completely up to you. And the response in this case will typically be like, okay, in this case, it replies back with some kind of weather information. It's 22 degrees unit Celsius, blah, blah, blah. Okay, but so now we have the weather in Boston in the API, but we haven't gotten a reply from the model, right? We asked it, what is the weather like? It hasn't replied yet. And the reason is obviously because it didn't know the weather. So now we need to do one more call back to the API. So let's take a look at that one. So now you can see we're actually passing it 3 messages. So again, we're passing it the first one because, again, it's stateless. It doesn't remember what I did last time. So I'm passing the initial question. Then I'm passing it the kind of response from my function. So I'm passing it now the knowledge about the weather in Boston. And also, again, like the function ones. And in this case, let's look at the response then. So now you can see first up that it says stop here. So it means that it's done. It actually could be that it would say you need to call another function now, depending on the case here. So this could actually go on now. But in this case, it realized that now I actually could reply back to the user. And it says the weather in Boston is currently sunny and has temperature of 22 degrees Celsius. So that was actually a 3-step process that you need to do to actually do this, the function calling. But this is now where the magic is. So the point is that these models now, the GPT models or the later versions, they are not trained, they are fine-tuned to do this. So they have become really, really good at, given a list of functions, pick the right function or functions and actually call them with the proper parameters and produce JSON back. And that is something that then the semantic kernel team decided that we obviously need to use this because this is now built into the model. So they did that by just implementing this in semantic kernel. So instead of doing all of that things that I just showed you, calling these 3 times, mapping between the JSON and your API, a lot of things needs to be done there. The only thing you need to do is that one. Just set one property and say, hey, call my functions if you find necessary. And it will do all of that for you. You don't need to do anything else. Then you can just invoke that prompt. And depending on what the AI will figure out, it will call one or more of your functions and produce the reply back to you. So again, it makes it really, really simple to use that. And this is the planner that you will be using most of the times. But there are other ones, as I mentioned. So there are some cases where the other planners can be interesting. One thing is around deterministic and potentially performance. So they have another planner called Handlebars Planner, and the point of this one is that this planner can actually generate a full plan, and it will give it to you. And you can actually, if you want to, you can save that plan and store it, and you can reuse it later. So that will give you better performance, but it will also give you the kind of the option of actually evaluating the plan, right? Maybe you don't want it to kind of just go crazy and call your plugins without you knowing it. So using this kind of plan, you can actually store that plan. Maybe you could validate it, make sure that it looks good, and then you can reuse it later. So in that case, what you could do is you use that planner, and then you'll get the plan back as a string, and you can store that one. And if you look at that plan, it actually looks something like this. So this actually uses the handlebar language so they just selected that language to represent these plans. So you can kind of see here how that plan looks now. Like it identified 4 different steps, and one of the steps it actually kind of does a loop and so on. So again, you could kind of validate this and save it and use it later. But most of the times you'll be using the function calling. So let's just do a few quick examples of how that actually works. So let's first let's take a look at the plugins. So let's just run that one. So let's just to show you how it works with a YAML prompt. So in this case, I'm just reading the prompt here, just from a file. That's the same prompt that I showed you on the slide before. And then the next step will be then to actually import that as a plugin. So you take that the definition, the YAML definition, and you import that into the kernel. And after that, it just becomes a plugin, like it would have been your own code. And then you can just run it. So in this case, what I'm doing here, I'm actually invoking that plugin explicitly down here. Because in some cases, you don't need a planner. You know what you want to do, so you can actually just call that prompt or call that function. Obviously, that would be a more deterministic way of doing it. So if I run this now, it will use that excuse prompt that I showed you before, so it will come up with an excuse. In this case, I'm passing it the input of customer meeting, so it should figure out why I was late to the customer meeting. So it says I'm running late for the customer meeting because I was being held ransom by giraffe gangsters who tied my shoelaces together with blah, 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 blah. But again, the point now is that looking at the prompt here that I showed you before, this is now stored separately. You can store this anywhere. You can load it dynamically, you can change it, and so on, without changing the application. And again, a lot of times this is what you'll be changing, not the application code, because the application code will be quite simple. It's the prompt that will change and be complicated. So that's the YAML part of a plugin. So let's take a look at the native one. And so in this case, I have a simple plugin that will call an API. So actually, in this case, it will talk to the Swedish radio API. So let's just take a look at how that plugin looks. So it's quite simple. It just has it's just one plugin, one method. So again, we have the kernel function up here, the attribute, and then we have the description. It says search episodes from the Swedish radio. Sveriges Radio inom parentes. And then we have the description, which is the search query. So again, given that I'm passing a prompt that has something to do with the Swedish radio, I'm asking about something, then probably I want to if I would use the planner, this is what it would use to actually call this one. And then I have some code in here that's not really relevant. It could be doing anything. In this case, it just fetches episodes from the Swedish radio API on a certain topics. So let's go back to this one and run it. So in this case, I'm passing it the query technique. So I want to have like tech-related episodes from the Swedish radio. So let's just run it to see that it works. And down here, so again, just getting the output from that plugin. So again, I'm not using planners now, just to be clear. I'm just invoking these plugins directly. And again, there are cases when when you want to do that, when you don't need a planner. Because the planner is more, it will spend more tokens, you'll pay more for it, and in some cases you know what you want to do. You just want to run a prompt or a custom plugin. But again, like the interesting part really is when you are using planners, but now you kind of hopefully know how the plugins work. So let's take a look at how to combine these things with a planner. So if you remember, the only thing I really need to do now, well, it's kind of two things. First up, I need to import my plugins. So in this case, I'm importing two plugins. First up, the one that I just showed you, the Swedish radio plugin. And then I'm also passing it another plugin, which is a file I/O plugin. So that's a plugin that can read and save files on the local disk. So I'm giving it two plugins. And again, the next part is this one. Oops. I'm saying that the tool call behavior should be auto-invoke. Again, that means that if the kernel now figures out that it thinks it should call a function, just do it. You don't need to kind of validate that with me. You don't have to do this. You can also say manual. Then you'll need to call it yourself. I'll show you an example of that later. But then I'll give it a prompt here. It says, get a list of all programs about technology that has been aired today on Swedish radio. List the programs with name, title, URL, and so on. Save the list of programs in a file called episodes.txt, and then return the list of programs back to the user. So again, this is like a query. That's something that I could say or write as a question. I'm not really referring anything to. I don't say exactly, about any plugins or. I'm just saying. I want to know what's on the Swedish radio today, right? And I want to save it in a file. So let's run this. See what happens. So I know that API sometimes is a little bit slow, so let's see how much time it is. So what actually happened now already is I can see now that we have a file down here called episode.txt. So I have a file. It was called episode.txt. So the planner figured out that I need to call that plugin because you asked me to. And it also responded back with the results, again, because I said return the list of programs back to the user, so it did. So I actually used both of those plugins now, the Swedish radio plugin and the file plugin, and kind of combined them in the right order to do that. I didn't really tell it how to do that. I just told it what I wanted it to do. So just to show you what's going on, if I can run the same example, but just with some added logging. So what you can do is you can hook into a lot of things. For example, the function invoked. That's a way for you to you could do logging. This is also a way for you if you want to kind of override things, validate things before anything is being called. You can do that before it's invoked and stop it if you want to. In this case, I'm just logging out what's being called and what's being passed to the function. So if I'm running this again, it's the same prompt down here. But if we're looking at the results now, you can see, for example, that the first thing it did was to call the search episode function, and the query was technology, because that's part of something that I wrote in the prompt. It's really up to the AI to figure out what it actually needs to pass here. Sometimes it can actually tweak that thing, depending on how I describe the plugin. And then I get the same results again. So the next thing we would see here is actually another call to my file plugin, which has a function called write, and then it will pass me the path of episode of text and then the whole content. So that's pretty cool. It now can actually do things on my local laptop just by calling the plugins. The AI is still running in the cloud, right, in Azure OpenAI. That's where the GPT model is running. But it just stands for the analytical part, like the reasoning. It figures out what needs to be done, but I am actually doing the calling, running on my local machine now, which obviously is what you will be doing within your company. So just to show you that what I mentioned before, that what you can do also is that sometimes maybe you don't want to have this automatical invocation. So what you can do is actually, I don't need to run this, but and it's a little bit more code here, obviously. But what I'm doing here, I'm using just the enable kernel function, not the auto invoke. So I'm telling it to figure out the function I need to call, but don't call it on my behalf. And that means that instead I need to kind of loop through here. So there's some code here. It's not super interesting right now. There's examples on the documentation site. But the point is now I'm actually invoking this myself. I'm just running through the function calling it and calling them. And so what I can do here, obviously I can do a lot more validation. I can ask users for permission before doing things, because these plugins now can do anything. They could post stuff, create stuff, delete stuff, and in some cases you don't want that without the user actually clicking an approve button or something. But in other cases you do. So this is another way of doing that. You can actually call kind of the plugins yourself in a kind of generic way, but still having the model decide when it needs to be called. So if we're combining these things now, we kind of have our Copilot, right? I haven't really looked at the system prompt. We'll be doing that to the persona. But we have the planners, we have the chat history, and we have the plugins. So if we combine these things, we can build, for example, a Copilot application. So as an example of that, I built that kind of as a demo. It started out as a demo example internally, but now we're actually using it more and more because I also wanted to kind of show this to our customers so they can realize that, what you can do with this technology, but with their own data. So I built like a Copilot for my company, Active Solution, and I had it talking to our internal services. So we're a consultancy company, and obviously we have some systems that are, our own. So we have things like time reporting, obviously, that's a third-party one. We have a system for resource planning, where we're planning our assignments. So say, hey, I'm working on that customer next Wednesday, on that customer next Thursday. That's information that we're working with a lot. We also have internal documents. We have a simple booking system for booking rooms and so on. So these are systems that we're using today, and they all have their own UIs. So I thought that this would be a good example of, let's build a Copilot instead. Let's use a chat interface and have it talk to these systems. So let me show you what this looks like as an example. So we have our own Copilot here. So this is copilot.activesolution.se. You can't reach it. Well, you can't log in, hopefully. Let's just switch to English. Okay, so, and again, it's kind of a demo application, so it has some, rough edges and so on, but it turned out to be, more and more useful, actually. So let me just do this. So just down here, then you can see it actually lists all the plugins that I added to it. So I have a few ones. This is the payment system, this is the planning system, the booking system, and so on, and we have some other stuff there. I also have one called math and one called time. Again, math, that comes back to the fact that you never want the language models to do math. So if I ask it to do some kind of summarization and so on, it shouldn't. It should call that plugin. Also, it doesn't know what time it is, right? The model has no idea what time it is right now. So, and a lot of these questions typically relate to, today or tomorrow and so on. So actually, to figure it out, it actually needs to fetch the time. So I think the first one I did, we have one called Shelly here. So Shelly is actually kind of a cloud API that you can hook up sensors to. So we have a few temperature sensors at the office that sense the temperature, and you can view a dashboard, but you can also use the API. So that was just the first one that I tried it. So let's just use that first as an example. So now what I can do, I can say, how hot is it at the office today? Like that. And let's see what it answers. So it answers back, okay, here are the current temperature at the office. So we have 4 of those sensors in 4 different rooms. So, typically one of them is a bit hotter, so it's 23.6. So it seems to be quite good weather back home in Stockholm. So again, it gave me the temperature there. And just can enable this little window that shows kind of under the hood what actually happened here. So in this case, I have a plugin called Shelly, and that one has 2 methods. So the first one will list all the sensors. The other one will give the temperature for a given sensor. That's all it knows that I have. So what it does is that it figures out, okay, first I need to figure out what sensors exist. So it calls that one. And then for each of those sensors, it calls it to get the temperature. Now, if I would have a function or a plugin that actually took a list in, it would call that one because it would be smarter. But in this case, I just have one, a method that accepts one of these sensors. And then I can see what it actually responded here. So for fun, then if I now say, what is the average temperature? What should it do then? Can someone suggest? Yeah. Exactly. That's what I want to do. I want to call the math plug. I don't want this now to just try to solve this math problem. It's not super complex, but it would probably not get it right. Another interesting part now is, so it needs to know the temperature. So do you think it's going to call the plugin again, the Shell plugin? And why not? Exactly. It also already has the temperature now in the history. So let's try this out, see what happens. So it's hopefully it's going to reply back with crash. That was weird. This has never crashed before. Okay, that's very strange. It actually gave me the right answer here. I'm not sure why it didn't reply. Okay, never mind. It actually did 2 calls to the math plugin. Well, first, we didn't call the Shelly again because it already had numbers. It called the summarize method on the math plugin. So it passed the numbers, and that returns the number. And then it called divide because it needs to do the average, right? And for some reason, it crashed here. But either way, you can see the response here, so 22.275. Now, if I would have, let's do a query again, but I clear in the chat and say, what's the average temperature at the office? Obviously now it's going to call the plugins again, because now I cleared the history, so it doesn't know anymore what the temperature is. So now, for some reason, now it replies back and says, the average temperature at the office is approximately 22.3 degrees. Okay, so that's a fun example, not really useful, but that was the first one that I did. So what's more interesting now is what I would typically want to know, okay, what's my plan for the week, for example? So if let's just ask that, what's my plan for the week? So now it's figuring out, I seem to be asking something about my resource planning, so I should probably call the resource system. The API, the active planning one, and now it replies back with the plan for me this week. So it says on Monday I worked on a Microsoft project. Tuesday I worked for a customer called Lania. Wednesday, Thursday, and Friday, I'm assigned to the utbildning talare, which means I'm doing like speaker engagements. In this case, I'm at NDC Oslo. So this is my plan for the week. So it's fetching live data now about my plan. So it's actually starting to be more and more useful in the way, and I can also talk to this, use the microphone and just talk to it. It's quite interesting to see how it changes the behavior. But what's really interesting now, I think, is because we have UIs for this, right? We can go to this UI and fetch the information. But it's really interesting when you start combining these things in the same query. So let's do a kind of a more advanced one. So first one I can just say, like, because we also hooked it up to the booking system where all the rooms can be booked. So I just say show me all the rooms. Okay, so it's going to list. Okay, so it's going to list me all the rooms we have at the office and so on. So we have that as well. But now let's say if I do this then. Find or let's do it like this. Book a room at 5 p.m. that is large enough for everyone that works with Lania, one of our customers. So now it's like a multi-part query here because it needs to fetch information from multiple systems now to actually be able to do this. So let's see what it does. And you can never, there's no 100% guarantee that this works. So also always interesting with the demos. But I'm now using the latest GPT-4 model, the Omni one, which is actually really, really good, and also a lot faster than the old GPT-4. So let's see what it says. So first up, it lists the employees. We have 4 people at our company that works with this customer, Helene, Ivar, Johan, and Fredrik. So it says, so we need a room that can accommodate at least 4 people. Available rooms that meet the capacity requirements. So it lists then the rooms that is large enough for those 4 people. And then it asks me, okay, should I book this room? Yes, book Surfen. I don't think anybody needs that room today, that Friday at 5 p.m. And now it actually does, just to confirm, do you want to book the room? Yes. Okay. Maybe to understand, yeah. Okay, so now it's actually booked. You can see that actually called the book room method that in turn actually did a booking request for that room. And just to show you, if I quickly show you that plugin called Active Booking, just one detail here. Here we have that function that it called, and what I want to show you is the description here. It says book a room, and then I'm also saying here, always ask user for confirmation before calling this function. So you can kind of also combine like instructions and so on, because this will just be part of the big prompt here, and that is why it actually did that extra confirmation. Now, you probably, in some cases, you want to have that extra layer of security that I talked about before, maybe do a explicit approval by the user from your application, but you can also use like the prompt techniques to kind of steer it the right way, and in many cases, that could actually be enough. Sorry? No. No, you can't trust anything with the language models, to be honest. That is just the fact that it will not, and it's not deterministic also. So if there are things that you want to make sure 100% that it's correct or validate before you call it, you need to actually implement that yourself and not just trust the prompt. In like 99% of the cases, it will be fine, but maybe not every 100th. So that is the tricky part of trying to like steer the moving elephant on top. Like it's so powerful, but you have to kind of trying to control it. So let me just for the final thing. So that was kind of a co-pilot application. Again, this is now a separate application, but you can also see this being part of like those applications itself, like sidebars. So I could actually do like a sidebar to our own systems to have a chat interface and kind of build functionality that way. So some of the complexity around this will be that eventually, already I have quite a lot of plugins there, and there are some problems with that. The first one is that I'm passing a lot of information every time now. I'm passing all those function definitions every time to the model, saying I have this plugin, I have this plugin, that plugin. That will, take time, but most importantly, it will also cost me money, actually. And also, it will be harder for the model to actually pick the right one. Sometimes these plugins will overlap a bit. Like we will have things like customer, for example, will appear in many of these plugins because all these systems referring to customers, for example, or project. And then it can be a little bit tricky. So if you're thinking more in an agent approach, what you'll be doing instead of kind of having like this big thing with a lot of plugins and trying to solve everything with the common system prompt, you can kind of think like you're breaking this up, kind of like a microservices analogy. Like you take the big system and break it down into smaller things. And that thing is often called as like an agent, which will typically be smaller and much more scoped to a specific task. So in this case, the persona will be really important because the persona will kind of define what the purpose and the behavior of that particular agent is. So you'll have, instead of having one big co-pilot, you'll have a lot of small co-pilots running around like small children. And then typically they want to talk to each other to actually solve the problem. And there are many patterns that you can do this, and this will be like a whole talk in itself, how you can build systems in an agent fashion. There's many approaches, and this is really like an area of active investigation and experimentation. This is not something we're doing yet with the customers, but it is like a really interesting area of research and like possibilities here, what you can do with it. So I just want to end with an example of how you can actually implement this with semantic kernel, because they are also working on that. And they're doing multiple kind of implementations of this. So I just want to show you one simple example, and hopefully you'll kind of get the idea then. So in this case, I'm setting up two agents. So let me just show you the code down here first. Here. So I have two agents. One is the software developer persona, and the other one is the conference organizer persona. And you can see when I'm creating it, I'm passing it like the instructions. That's the persona, the meta prompt. I'll show you that later. I'll give it a name, and I'll also give it a kernel. So again, the kernel could be different here. I could use different models for different agents. So once I have those two agents, then in this case, I will create a group chat with them. So I'm creating a group chat by adding these two agents. And then interestingly enough, I'm also having these settings, and as part of that settings, I have something called a termination strategy. Because the thing is, once I unleash these agents into the wild and they start talking to each other, when should they quit? What is like the end? When should they terminate? That's an interesting question and quite important to get right. So in this case, I'm actually passing it like my own implementation of that. So this is actually a class that is down here. So so this is a very simple implementation, but what it does in this case, it will just look at the last message and see if that message equals looks good to me. It should end. And the reason why that is really up to these prompts. So let's just take a quick look before I run this. So again, the purpose here is to write an abstract for this conference. That was like my demo example here. So the first one is, let's look at the software developer. So it says like, you're a software developer, you love to share your knowledge, blah, blah, blah. Your goal is to write and refine a proposal for the NDC Oslo Developer Conference. So the purpose of this agent is to write a proposal for a conference talk. And I'm giving it some kind of the structure to use, some guidance. Also telling it that you will be getting like suggestions on how you can refine your idea. And it says it's only implement one suggested improvement at a time. So that's the developer persona. And then we have the conference organizer persona. So that will have another instruction here. So you're part of the team. Your goal is to actually evaluate sessions. I'm giving it some guidelines on how it should evaluate the proposal. It should be relevant. It should be clear. And I'm also giving it some kind of fake instructions here just to kind of prove the point. I'm telling it that proposal can't be longer than 100 words, and it has to contain the term AI overlords. And the reason is that because this will create a longer session here. Only suggest one required or suggested improvement at a time. So let's run this and see what happens. Okay, so clear and .NET run. Again, you never know what's going to end up when you run these things, so that's also always interesting. So now I'm also starting this. I forgot to show you that, but I'm starting the conversation with like write a proposal with the following topic: developing AI agents with semantic kernel. That's my session now. So that kind of starting the conversation by that, and then I'm passing it to agents, and now they're going to start working here. So what should happen now is that the developer should pick this up and produce an abstract here. So it has an abstract, an outline, a lot of stuff here about semantic kernel and so on, key takeaways and so on. And okay, that was kind of depressing. Okay, let's try it again, because that wasn't good. It should be like a conversational session here, because typically it won't include things like AI overlords, and typically it's longer than 100 characters. Okay, so now it works a little bit better, I think. So okay, again, I get to the proposal here, and then the organizer now chips in and says that, okay, the proposal is clear, engaging, and relevant. However, it is longer than the 100-word limit. Please revise it to meet the word count requirement. So then the developer sees that and creates a new proposal. And then, let's see, the organizer says it's still beyond the 100-word abstract limit and does not mention AI overlords. Please include this term. Then yeah, exactly, passive aggressive. And then it tries again, and let's see if it has AI overlords somewhere. Yep, here we have it, AI overlords. And yeah, maybe it's below 100 words, I'm not sure. But now it says, looks good to me. And that kind of terminates the session, and actually terminates this session as well, because I'm out of time. So thanks a lot for attending the session, and hopefully you'll be going home and building your own co-pilots. Thank you.